Hello, can you hear me, guys? If you can confirm. Hello, guys, am I audible? Hello, hello,
Yes,
hello.
yes, you are audible.
Okay, thanks. Should we wait for a couple of minutes for others to join, or how's it?
Mithun, we can wait for another 1 or 2 minutes and start off.
Sure, yeah, sure. Thanks.
Hey, Mithun, we can start.
Okay, guys, let's begin. Guys, are you able to see my screen?
Yep.
Yes.
Yeah.
Yes, Matan.
Yes.
Okay, great.
Good evening.
Good evening. Okay, just 1 second, guys. I just got a bad throat. Okay. Yes, very good evening. In case my voice is slightly hoarse or different, just please bear with me. So, what I'll speak about in today's session is what is called as machine unlearning. Sorry. So, we'll look at different things in unlearning. I'm given to understand that you've already finished machine learning, at least the basics of machine learning and such things. So, you will have some bit of understanding about machine learning. Okay. So, insofar as the agenda for today's presentation is concerned, I'll just give you a brief insight about machine learning. Right, we'll touch upon the background of machine learning. We'll look at what's the definition of machine learning and under what circumstances or situations can we use machine learning. The need for machine learning, right? Challenges, different application areas. What does the future hold for machine learning? And we can also we can look at 2 or 3 examples in the lab. Okay, that would be the lab session. So these are the 7 or 8 agenda points that I have. I may cover some additional things here and there depending on how much time I have. Okay, so before we go on to machine unlearning, I just wanted to sort of quickly recap. I know that you have learned some of these things, so at the risk of repetition, I'll just take 5 minutes of your time to recap machine learning, and then we'll be able to understand unlearning better, right? So I'm sure you may have seen this picture somewhere. So you have machine learning, right? 20 years back, nobody called this as machine learning. This subject is machine learning. They used to call this as data mining, which is always, we'd always begin the subject of learning by using 2 magic words, which is pattern recognition. We would recognize pattern, curves, and certain repetitive rules and such things. Correct. Typically, when we say machine learning, decision tree, neural network, support vector machine, let's say a priori algorithm. K means cluster analysis. All of these things would come into picture. They are mostly rule-based algorithm. Now, at a very high level, you can see you have unsupervised learning as well as supervised learning. In supervised learning, we tend to have an easy time if the data is already there. There is what is called as ground truth. Ground truth means basically having the dependent variable, or if you don't have it, basically you have to read through every row and you have to fix the ground truth, or you have to arrive at the dependent variable, which is a bit of a challenge because I remember having worked for one of these video segmentation problem, wherein you had the days of COVID wherein people would try and maybe copy, right? But we could not have offline examination; it had to be conducted online because it was a COVID era. So, on what basis would you classify a particular frame, a particular frame as a case of suspicious, right? Maybe he would blink his eyes too much, or maybe he would try and fetch something from the left hand. Maybe he's trying to change the keyboard very subtly. All of these things would be patterns or whatever, right? Now, for each frame, we had the data, we had this footage, whatever, but we had to look at this and firstly, at least to kickstart the process, we had to label it, right? And that is an intensive process, arriving at the ground truth. Now, typically, when we work in a classroom, we can't spend so much time, creating the ground truth or having the labels, predefined labels. So there are already predefined labels and such things which are given to us, which is bed of roses, very easy for us to then apply dependent or independent variable, right? Otherwise you have to create this dependent variable. It requires a lot of time, effort, manpower. One person cannot do it because if you have 5,000 images, you may need around, let's say, 10-15 people who dedicatedly work on this and then label this. Okay, so you have supervised learning, and then you have reinforcement learning, which is mostly used in gaming and such things, even in recommendation engine, which works on the carrot and stick policy. The model learns something well, learns a pattern well, basically you reward it. If not, basically you punish the model. And then basically from here, from the supervised learning, you can further go on to do classification, regression. In the case of unsupervised learning, you may have dimensionality reduction, clustering, or so on and so forth, right? And you have various things like recommendation engine, so on and so forth. This is at a very, very high level. Just remember 2 ideas: patterns, learnings. We are training the model to learn certain characteristics in machine learning. Now, this is the theory aspect of it. But practically, if you have to get your hands dirty, right? If you have to build an end-to-end machine learning project, you will go through the sequence of steps, right? I'm sure you have gone through the sequence of steps, right? And many times we think that building a model, a support vector machine or a neural network, that is what is my job. Trust me, guys, that is the easiest part. Anybody can build a model. You have so many codes and such things with Chat GPT, Hugging Face, so on and so forth. You have so many ready-made codes. You have to just change the data. But the real challenge comes about the preparation of the data. Correct. So I'm just showing you how you can perhaps run through the sequence of steps. You have to assemble the base data. You have to check the data quality, right? Once you load the data, you check the data quality. And here, basically, you do some straight liners analysis. If it's a typical market research data set, or you do outlier analysis, you do missing value analysis. Within this missing values itself, you may have different degrees of missing values. Above 13% typically in pharma, they may not touch because it's a life and death situation, right? So if it's 5 to 10%, you're slightly unsure. Less than 5%, you may use some level one techniques like mean, so on and so forth. Then you go on to split the data as training and testing. You run the model on training. Why? Because you are trying to capture the patterns in the data set, right? The training data set. If the same patterns are present in the testing, you will go ahead and apply. Then you'll go on to score the data set. Cross validation you'll do between the training and the testing. If it is consistent, well and good. And here I'm just giving an extreme example wherein it is not consistent. You have a low accuracy problem, lack of robustness, so on and so forth. So these 6 or 7 steps that I've listed here, you will do. Now it looks easy, guys, but when you try to operationalize this in a real-time scenario, preparation of the base data, if the data is stored in some third-party database like SQL or whatever it is, you have to assemble the base data. You have to do a lot of joins and such things. And then once you join, basically you'll get a lot of duplicate cases. Now, then one more question, business rule you have to apply, which duplicate, because you can't build any model in the presence of duplicate cases, right? You have to remove. How will you remove? That's one more question. You may have to write one more logic to pick up the most recent case as opposed to the latest, as opposed to the oldest case. So all of these steps you have to go through, correct? So, and this entire sequence which I've just shown here may itself take a month sometimes, or if you have a team, maybe, or if the data is much cleaner, it may take maybe, let's say, 1 week, 5 days or 7 days, depending on how much time has been allocated for the project. Now, just keep this slide in mind because I'm going to make a reference to this slide at a later stage. Correct. Now, we used to think that machine learning models are difficult, right? Take the input, feature extraction, classification, and then you classify an object as car or not car, cat versus dog. In the case of deep learning, which mostly comes into picture for unstructured data, this would be even more difficult. Why is it even more difficult? It is even more difficult, or let's say, let's take the example of large language model. You may have billions and billions of parameters. Let's take the example of GPT 3 or 4, right? It may have billions and billions of parameters which are trained. And somebody would have done the hard work of going through these 7 steps from the scratch, correct? You have to, in the case of large language model, you would have collected the data from internet. Now, you may have trained your model basically on the entire Wikipedia, maybe Shakespeare's novels, William Wordsworth's novels, language translation. One link may point to another link, so on and so forth. And you have finally, corrected this problem as well, wherein you have inconsistent accuracy between training and testing, right? So the original model may lead to over prediction, or it may be overfitting. So to correct this, basically you have to arrive at the optimal parameters, as in the case of deep learning. And for you to arrive at those optimal parameters weights, basically it is not so easy, right? It takes a lot of effort, right? Now, if I were to say, after doing this hard work, correct, after doing all of this hard work, basically, right, this hard work, if you have done, it simply means that you have learned something from the data, right? Your model now is in a good stage wherein it has learned certain patterns and characteristics and features from the data, and you're all set to predict. Now, when machine learning itself is in a way so resource intensive, there's computational power and such things involved, then why are we thinking of unlearning the learned pattern, right? Why should we unlearn? Correct. So that is where basically today's discussion comes into picture about machine unlearning, right? So let me just give you a bit of a background as to necessity of unlearning. And this machine unlearning is not really an old subject. It does not have a history of 30 or 35 years. It's a relatively new subject, correct? So if you get into this, basically, you'll see very little material. And here and there, you may see blogs which are very, very general. No specific points are given, correct? And it's a subject which is in the process of evolution. So mostly whatever I have been able to learn and pull out, they're all from research papers. I'll suggest a few research papers maybe at the end of the discussion, wherein you can read and you can maybe gain more insights from this. Okay. To give a formal definition of machine learning, it's a typical procedure. It's a subfield of machine learning itself, wherein what are we trying to do with this machine learning? It refers to the process of removing the influence of certain data points. So in the chat GPT example or open data, if somebody puts a case against me saying that, boss, you are using my data, correct, and it is affecting my privacy within double quotes, correct, I don't want you to use it. Just think of it. All the hard work that you have done in this stage, you have gone through all of these steps, perhaps more than this. This is for structured data, I'm saying. For unstructured data, large language models typically work on unstructured data. You have to do your stemming, lemmatization, regular expression, all of these things you have done for the for this one person's requirement of privacy and such things. Basically, what do we have to do? We have to basically flush out all the patterns that we have learned, and we have to retrain the model. So that is what is the first impression that we get when we look at this. Machine unlearning refers to the process of removing the influence of certain data points or specific data points. So the challenge before us is, it is not like putting a nuclear bomb and one extreme is basically you rebuild the model from the scratch, which I will always try and avoid. You know why? Simply because model is built once, it is applied multiple times. Right? It is like building a house. You build a house once, and if there's any problem, water leakage, this, that, and all, you address it at that level. For every problem, you can't rebuild the house again and again. So the extreme step is basically to retrain the model. Retraining the model means what? I have to go back from the scratch basically for one person. And is it the and you have removed this person? What is the guarantee that you'll not have privacy issues or these objections coming in the next month? So February again, if 2 people or 20 people ask me, boss, remove my data, should I again go through this entire cycle of 7 steps or 8 steps to unlearn a pattern which we have spent so much of time, efforts, money in learning? That is the question. Therefore, the most important word here is specific data points. We are trying to remove the influence of very, very specific data points from a trained machine learning model. A better word would have been from a already trained machine learning model. So you have a model which is already trained, you're happy with this, but some fool, some idiot comes to you and spoils the party by saying that, sir, please remove this data point, I'm not happy with this. Correct? And once you are basically once you remove these specific data points from a already trained machine learning model, now your model, the challenge before you as a user is that this newly obtained machine learning model, it should act as if those data points were never used during the training in the first place. That is the challenge before it. I'm removing certain data points, right? The obvious thing is, if I'm removing certain data points, that patterns will change. My new model may not reflect the patterns because I've removed it. Right? But as far as possible, to the best of my abilities, I would like to have the new machine learning model behave as if it has never seen the data point. So this is the challenge: accuracy versus privacy. So that is the discussion here, right? Privacy, I cannot compromise, and I'll tell you why I cannot compromise too much on privacy. And accuracy, again, basically, I would like to have the highest levels of accuracy without compromising too much on privacy. So that is the entire science of machine unlearning, correct? Now, why machine unlearning now? Correct. As I said, basically, it is not a very old subject. Uh, around 2017 or 18, a lot of people spoke about explainable AI and such things. So every once in 2 years or 3 years, you'll see this hype or buzzword in this field. Now, basically, there's quite a bit of buzz on machine unlearning. We'll just try to unpack some of these things about machine unlearning. So when we speak about machine unlearning, guys, there are some points which we need to keep in mind. There are certain features and ideas that you need to keep in mind. See, machine learning is everywhere. We have to, whether we like it or not, basically, we can accept the fact that machine learning is everywhere. It has allowed us to do a lot of things like object recognition, chatbots, online recommendation engines, and sometimes to a high degree of accuracy. But the challenge here, which I've mentioned, is privacy. So if privacy is a problem, then basically you will have to use this. Now, what do I mean by privacy? So uh, in developed countries, in India, it may not be so much of a problem, but in developed countries, guys, people are given what is called as right to be forgotten, right? I'll just clarify this point at a later stage, but just remember that privacy is a problem, which is this is a legal right that is being given to to almost all the citizens in US. Now, here, what we try to do is basically, if there is a request which is coming my way, saying that please delete my data, I'm not very comfortable with you having my data. Why does this come? This may be for a variety of reasons. One is because I'm genuinely not comfortable with a company like, let's say, Amazon or Netflix or Facebook using my private data, right? There could be, there could be a lot of, sensitive data, right? Sensitive data. So I want you to delete this data. Uh, the simplest thing is basically in a database, you put a delete condition, delete. But the challenge is basically this data point and several other data points might have been used to build many machine learning models. So at any stage, basically, if you are found to have used the model which contains that data point which who has demanded privacy, you again can be sued and you may have to pay millions of dollars. So it may not be as simple as going to your database, Teradata or whatever it is and deleting the data point. You have to remove the influence of this data point on your large language model or AI model or whatever it is. So deleting the data and its influence on AI models such that its influence itself basically disappears. So this is the first challenge we have. So in other words, basically, I have to teach my AI model to selectively forget. Selectively forget basically means targeted amnesia, right? Selectively forget. I may have to update a trained model so it can act as if it has never seen the data point, correct? So this, as I said, basically it happens for a lot of reasons. Typically, I'm given to understand when it comes to your health details, your BP status, you may have a strange disease and such things. And if you go to the hospital, you give all of these details. The hospital basically has an arrangement with some third-party data vendor. In UK, it is Experian. There's an organization called as Experian and Olympus. They collect this data, and any organization, if you pay some money, they will give that data for you to train. Now, suddenly I'm thinking, okay, boss, all my sensitive details and such things basically somebody is using, and I'm not even sure. So this is where basically I have the right to demand to be forgotten. This right itself says right to be forgotten, right? I demand that you forget my data completely. Second one is basically, private details I've told you. Second one is basically could be a situation. Let us say uh, uh, when 7 months back, in US particularly, basically, guys, uh, there's something called as oak culture, which is very, very prevalent. Oak, the wake and oak, right? You open up, you're enlightened. So there's a leftist movement, and they come up with new theories every now and then, right? So in BBC, if you look at BBC, if you look at BBC, right, a very popular broadcasting service, they have officially recognized 112 categories of gender. 112 categories of gender, right? In India, we mostly may look at 2 or 3 categories of gender. There it is 112. So I will not be recognized as a male. I will be recognized as the cisgendered male. Somebody could be recognized as a cisgendered female. So 1 or 2 years back, the model which was built, there basically my gender was male. Now, if I've decided to identify myself as a cisgendered male or cisgendered woman, basically just think the model has not been trained to predict for cisgendered male or cisgendered female. And in your data of 1,000 people, 20 or 25 or maybe 200, X number of people want their gender basically to be revised. How will you do it? Can you revise the entire data? It's a question mark. Correct. Second one is basically your sexual preference, sexual orientation. Basically, these things basically people change, right? And when they put a request saying that please put change these details in the original database, it's a very easy thing for them to say. But for me to retrain the model based on this becomes a big challenge. Fourth one is basically people's preference and taste change. When I say taste, 1 year back, let's say I like to watch rock and whatever it is. Now, basically, I am more into Kishore Kumar songs and such things. But the model which was trained 1 year back, because I used to play these songs nonstop, it has learned that I like rock, band, jazz, whatever, blah, blah, blah. And now it is making those recommendations, those songs. My tastes have changed. So all of these are wrong recommendations that you're making me, or my need state might have changed, right? In the month of December, let us say it was my sister's wedding. Now, because it was my sister's wedding, in a typical wedding, basically, what do you do? A brother may purchase a lot of things, correct? A brother may purchase many items. It could be a sherwani, it could be a pagdi or whatever it is, typically which people wear for their during the wedding, right? It could be kurta pajama or kurta jacket, whatever it is. It could be a turban, it could be a necklace, a watch for my sister, some perfume, and sehra, whatever it is, correct? The model has learned this pattern the month of December when I went. Now, the model is continuing to make those recommendations of marriage related stuff today. Today, 7 months have passed, the marriage, the special occasion is over. So I am not in that state of mind wherein I will respond to these items. So this becomes a problem. So the model's predictions are outdated. The training data, some of this training data might have been outdated. Your need state has changed, your tastes have changed basically, or sometimes it could be plain, request wherein people are saying, boss, just delete my data. I have a right to be forgotten. Second one is basically security problems. Security problem means what? When I say security problem, there is something called as data poisoning. What is data poisoning? These are attacks on the model themselves. Most of these models which we build, they are very vulnerable to what is called as data poisoning. What is data poisoning? This is nothing but malicious data which deliberately gets injected, particularly by hackers and such things, into the training data set, right? If my competitor is new, let's say Netflix, and I know that they're making a lot of money through recommendations, I can basically ask all these hackers, it could be 10 or 15 people, pay them money, inject some data into it, and basically pollute the data. The goal is to make the model sort of mess up as much as possible, misclassify things to generate harmful content, toxic substances, and such things, so that Netflix's recommendation engine itself is corrupted and it starts making bad recommendation, and there basically sales, profitability, everything basically gets degraded. So this is a problem which we typically call as model poisoning, and here again your machine unlearning is the way. So if you have privacy protection, machine unlearning is the way. Security issues and such things, basically machine unlearning is the way. As I mentioned, basically you may be using a outdated model. So there's something called as model drift. There's something called as data drift. Data drift is when the data characteristics have changed. Model drift is when the model is not able to recognize new patterns. Correct. It is predicting old based on the old patterns. Data drift. I'll just give you an example. We had a client by name Aviva. I may have given this example. I was working for WNS, and their our client was Aviva. They had data from 1850s, ship data, this data, everything, correct? Now, if I'm using that data today to build a model, 1850, how many people would be alive today? Almost 200 years have passed. A lot of people would have died, correct? A lot of people would have changed their address. A lot of people would have suffered some disease. COVID basically wiped out at least one member in the family. So how are you taking all of these things into account? Do you want to build a model based on dead people or most recent data? Most recent data, if you put a filter, basically, I may get barely 30 or 70 records, which is not good enough to build a model. So all of these things are a problem. So when you are building a model on outdated data and such things, that again becomes a problem. Regulatory compliance is there, and bias mitigation. Bias in the sense, basically, while having the data itself, for some reason, the model may be very, very biased. So if you look at ChatGPT and such things, if there are certain questions that you ask, and the questions are related to a particular religion and such things, right? It gives you a certain opinion. If the religion is something else, basically, and your questions is basically related to some other religion, basically, it gives you maybe some other very, very negative or a very hostile kind of a viewpoint. So it's a case of garbage in, garbage out. There is no large language model, small model which is 100% proof. All of these models are trained on the data. If the data is poisoned, the model will learn from poisonous data and will mispredict or give wrong prediction. So all of these things, if you're suffering privacy issue, security issue, adaptability, or regulatory compliance, basically, if you have basically, or basically bias mitigation, machine unlearning would be the answer for any and all of these problems. So let's just dig deeper into this. So typically the feature of machine unlearning, whenever we speak of machine unlearning, it is the art of digital forgetting. This is what we say. It's the art of digital forgetting. Second one is we use this expression subtractive capability. I am trying to subtract the influence of certain data points on the overall quality of the model. Next is basically I'm trying to remove the data's influence. Now, this is an emerging subfield of machine learning itself. It is almost like a counter wherein machine learning's job, as I initially told you, is to learn patterns. This guy's job is to surgically within double quotes, surgically cancel those patterns which my machine learning model has learned. Now, it is not like a nuclear bomb. I'm just giving this example. Now, recently you saw this India-Pakistan Galata. There was a lot of problem, right? We were trying to put bombs. They claimed that they put bombs, whatever it is. Now, we use a word this thing, target, surgical strike, whatever. In machine unlearning also, you're doing something similar. You're surgically targeting certain data points, not all the data points. To put a nuclear bomb in a China or Burma or Sri Lanka or Pakistan is easy. Good and bad people, or everybody will be killed. Here again, I don't want to retrain the model. There is something called as forget set and trained set. Forget set is the set of people whom you want to forget, whom you want the model to forget. That is almost like a surgical strike that you're doing on selected data points. And there are certain strategies which we can do. We'll discuss that. It aims to remove the influence of certain specific data points from the training data. Prashant, please tell me.
Mithun, just I'm thinking and whatever you are speaking, and then I'm trying to connect it. And then I just build an analogy of these things. It is something like we are fixing bugs into the machine learning.
Yes, you can. That's a good
And the
example.
people have modernized this keyword of bug fixing in a very fancy word, machine learning.
Yeah,
Seems like that.
yeah, bug fixing could be mostly related to mistake and such things that you have done in the original
Yeah,
program
but
code
if you
and such
see,
things.
means last 10, 15 years or 10 years, people started building the AI universe. Okay, they started AI universe building, and they've gone into full flown, and they started everything to make it learn by the machine. Now, when things get learned, people get matured, or this process get matured. Now they are realizing, or the a counterpart is realizing that, oh, these are the things which need to be, we must have to be taken care. For
Yes,
example, you build a software, and let's suppose this software has been built by a very software engineer, or any fresher from the college, and he
yes,
built everything. Now when he went to this to showcase to the experienced person, they mentioned that, okay, it should have this feature, it should not have this feature, it must have this feature, this is
right.
wrong, this is right. I think this is going on in the
Yes, you're
current
right.
world, and
You're
the
right.
people have made this as a very creative
Fancy.
or a fancy word. Yes, machine
Yes,
learning. It's
unlearn. Yes,
almost we are fixing the things into the system which
yes,
we are trying to build.
correct. It's maybe you can, many times when I was working on this, I just got the same feeling. It is old wine in new bottle. That's it.
Exactly.
To a large extent, right? Yeah.
Yeah, we are trying to implement, SDLC, like, okay, we will find something, we will improve, we will release one part, release two, release three, something like it's going on.
Versions, yes. Version 2, version 3, version 4.
Yeah.
Yeah. Yes. Yes, Sunil.
Yeah, Mithun. Although you have answered already this question, but I'm again asking, like, so making any trained model, to making it unlearn some certain data points, but it will also takes, some resources or something, some
Definitely.
efforts. So instead of doing this, is it not easy to, delete that data points from the original, data set, and we can, train that model?
See, when you straight away delete the point, no, what if the influence of those data points on the model is very, very high? Right? If the influence is very, very high, the moment you remove, it's like, Indian cricket team, the influence is high because Virat Kohli and Rohit Sharma's influence is very, very high. I remove them. What happens basically? Suddenly the performance of the entire team comes down.
Uh, no, 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 I'm talking about only those data points which we wanted to,
Yeah,
unlearn.
correct. Those data points which you want to unlearn, if their influence is low, the model may still basically work very, very well. No problem. It's a happy ending for you. But if the influence on those data points on the overall quality of the model basically is very, very high, then basically the model's performance itself, the model starts making wrong prediction. Wrong prediction basically means that you have there are certain newer patterns basically which have emerged which you're not able to predict properly.
Okay.
So both cases are there. If it is negligible, basically it's no problem. Nobody is stopping you from simply deleting it. But many times you'll see that the impact of these the points which we want to delete may be very, very high, and therefore basically all the problems come.
Okay. But how they making
I'll
impact?
tell you. I'll tell you. I'll show you in the subsequent
Okay.
slides. Okay. So we've discussed a couple of points. Let's just skip this. Okay. Now, see, guys, typically, guys, when we talk about these large language models, correct?
Nathan, I got sorry interrupting you. Can you go
Yeah,
back,
sorry, please.
please?
Yeah.
Previous slide. So according to your experience, what could be the top use case for machine learning? Maybe
Typically, healthcare. Healthcare is the best example wherein patients come with sensitive data. Their data is basically included. And once their data is included, at least from a US point of view and such things, sensitive health data and such things are basically changing hands. So that is a great this thing of your machine unlearning. However, I've got three applications as well that I can talk about in the next few slides. Second one is financial data. If by some chance, basically financial data is basically used to train the AI model. And then I realize basically I'm not comfortable with some company having my financial sensitive data, then again, it's a problem. Third one is basically this woke culture and such things, and because of which basically gender orientation and your preference, sexual preferences, basically that kind of data which you may consciously or unconsciously comment on or not comment on in YouTube, in Facebook and all these social media posts, that may be used. Copyrighted material, again, wherever you have certain very sensitive copyrighted material, untrusted material, and such things, basically, wherever there is scope for the AI model to pick up these details, that's where basically somebody can basically come and put a case, or somebody can not case itself. They can say, boss, I have a right to be forgotten from your system.
so you mean to say regulatory compliance is one of the major
Yes. I'll talk about regulatory compliances as well.
Got it. So will you also cover at high level EU AI Act?
Yes, EU, not, yeah, I'll cover about that. I'll talk about that.
Fine.
Suresh, yeah.
So how is the relevant to the e-commerce systems this is working and the mission in the today's topic?
See, e-commerce, because basically, if you look at e-commerce and such things, most of their business comes from online recommendations, correct? Recommendation, right? So you may have gone to their website. Let's say Amazon itself basically may have studied my past behavior of 5 or 6 or 7 purchases that I have made. And once basically it has learned in the past, basically, let's say I'm a sports buff, I love to buy sports items. So it has learned that Mithun basically learns sports related things. And therefore, next time, basically, when I go to Amazon or any of these e-commerce, basically, it makes a recommendation of sports-related things. Now, my need state may have changed, right? If the need state itself has changed, originally the model that you had built, which is going to make a prediction, may have given high weightage for all the sports-related items. Now, basically, let's say I'm just giving an example. I may have suffered a fracture, I may have suffered a ligament tear, and for the next 2 or 3 years, there is no scope for me to use any sports related there's no scope for me to do sports related things. But whenever I go to Amazon, I'm still getting recommendation of all those sports related items: buy a racket, buy a cricket bat, buy a ball. It's all misprediction and such things. So I'm tired and tired of this. I may go to Amazon and say, boss, whatever earlier data you have, please remove it, basically, because I'm because of your wrong predictions and such things. We get bugged. We all like to receive messages and recommendations so long as it is relevant to us. If it is irrelevant, we basically we would like to at least inform basically, boss, don't make this recommendation, or in other words, right to be forgotten. Please forget my old data. Does that answer your question?
Got it. Got it. It's
Yes.
like a personalization. You mean to say personalization?
Personal, yes. Personal sensitive data must be deleted. And almost all of your recommendation engine today talk about hyper personalization, not even personalization, hyper personalization. So wherever there is hyper personalization over a period of time, basically need state change. So your algorithm needs to be adapted, basically. So when I make this request, basically, I'm demanding the company for right to be forgotten.
Got it.
Yes, thanks.
Thank you.
Rajesh? Rajesh?
Mithun, actually, like when we train the model, will be using the data, right? What
Yes.
if we mask it? Because most of the concerns I see is like a privacy thing, and there is a third reason, that is adaptability enhancement. I think that definitely we should be taking care. But why exactly we come across privacy concerns?
See,
Uh,
within
because
privacy, yeah, please tell me.
in most of the cases, we'll be predicting the values or we'll be forecasting some numbers, right?
Mhm.
So here, like where exactly we see the privacy concerns?
See, uh, when we say privacy, basically, many times, basically, there could be a case wherein people may ask selective information to be deleted. That is one case, basically. Or you may be comfortable, basically, having your data masked. But there are equally a lot of cases, basically, wherein I may not be comfortable. I want my entire data itself to be deleted. As I basically mentioned, basically my sensitive health data or my sensitive financial data, my how much I own, basically where I've made all the investments and such things. If that piece of information is basically used and made public, basically that's I may not feel very very comfortable. So whenever it comes to health data and such things, even half masking may not be appreciated. Let us say, basically, in the facial recognition image, I have a series of basically child's faces that I've used to train. Now, many countries may basically object to it. Child's faces and such things, basically, how you can use. So this becomes a problem.
Got it.
If you mask the child's face, then basically it's a facial identification or recognition model. You're masking the child's face. Then basically, the moment you mask the heart of what you want to learn, basically your machine will start mispredicting, or its prediction goes haywire.
Got it. It's like
So
they are, I mean, within the training itself, they want to,
yes, within the training itself, yes,
it's not about data leakage. It's
it is
about,
not. One part of it may be data leakage, but that's only a small part of it.
got it, got it.
Yes,
Mm.
yes. Anybody else? Somebody else raised the hand.
Hey, this
Okay.
side Mukesh.
Yes, please tell me. Please tell
Yeah.
me, Mukesh.
Days back or a week back, I heard a news that US government, like the Trump government, said that they will delete the models which, as per them, they think the biased one, and they will set up their own data center and do one as per the law policy, the US policy. They will create the new data which, as per them, like unbiased. So can we consider this case as well under like unlearning and
I see unlearning is basically like a surgical strike. From what you have
Mhm.
said, basically, if they're completely, junking the old model itself, that is not unlearning. That's a case of retraining from the scratch.
Okay.
Retraining from the scratch is a extreme case, basically, wherein basically I have to double my efforts. I'm trying my best. This entire machine unlearning gives me a way out of retraining. I'm avoiding that goal, or I'm avoiding that idea of retraining because it is computationally not feasible.
Makes sense.
So in the case of Donald Trump and what the example that you're talking about, setting up the server and such things, basically, I think they're trying to do from the scratch, which is retraining.
Correct.
Okay. Yeah.
Thank you.
Yeah, no problem. I've just spoken about this sensitive data, right? Retro move this.
Mithun, last question.
Yes, please.
Chintan here. So question is there a difference in the machine learning and in some cases we don't want certain data should be, we have given the data to the algorithm, we have data, but now we don't want that data to be counted. Example, suppose during COVID, stock market crash, right?
Correct.
So when I doing a prediction, I don't want to consider it because this is something impacting my algorithm, right?
Correct.
So is it the same thing? And I mean, unwanted data you are removing, or unlearning is something different?
See, unlearning is something very, very different. Primarily, I just, if you can wait for 5 minutes, I think your questions will be answered. Just give me 5 minutes. Okay. So, okay, I was just talking about this sensitive data, untrusted data, copyright data, faster than retraining. Okay. One is, guys, this is what I think most of you may be thinking of from the data base, basically. Why don't I just use a select star from or and delete, wherever this is greater than this? This is a very simplistic situation. But the thing is, basically, this you can do, no problem, right? But if this person's data has already been used to train a deep learning model or a AI system, basically, then that becomes a huge problem. How do you remove the effect of this person on a trained model, which has already been trained? That is where basically your machine unlearning comes into picture. Okay. Now comes basically some of the guidelines, correct? Uh, we have some of these laws, guys, regulations, and such things, and we can just go over some of these rules and regulations at a very, very high level. Now, one of the most popular of these laws is what is called as GDPR, right? It stands for General Data Protection Regulation, which came into effect in 2018, General Data Protection Regulation. Where is it? It operates in European Union. Then you have what is called as PIPDA, right? Its full form is basically Personal Information Protection. PIP basically Personal Information Protection and Electronic Documents Act, right? Where is this where is this applicable? This is applicable specifically in the country of Canada. Then you have what is called a CCPA. Now, this is specifically in California, right? CCPA stands for California Consumer Privacy Act, correct? Now, these regulations, what is the larger goal? Their main aim is to protect individuals' personal data, what personal within double quotes, correct? Your gender orientation, your health detail, and your financial details, your preferences for a particular political party or not, whatever it is. All of this personal data basically should be protected and provide guidelines for the organization. They are also providing guidelines for organizations to handle sensitive information. So mostly this unlearning, which we are talking about today, has become popular because of these guidelines and such things to meet regulatory compliance and such things. Tomorrow, if auditors and some people come, basically, I can say, boss, these many people have submitted a request, and I've made sure that basically I have not used X, Y, Z, A, B, C's information in either the data. I've completely deleted it, or I've basically made sure that its effect is removed from the model. So only after these regulations, it gained ground. Otherwise, basically, machine learning, nobody took it so seriously. So this is one important point that you need to keep in mind. Let's look at GDPR, guys. Now, when we speak about this GDPR, particularly the simple way to understand your GDPR, which is, as I mentioned earlier, basically General Data Protection Regulation, General Data Protection Regulation. Now, as per 65, 66, and Article 17 of the GDPR, this is a clause. The data subject means person, shall have the right to obtain from the controller the erasure of the personal data concerning him or her without undue delay. Typically, it is 1 month. Within that, basically, the company has to erase it if there is a request that is submitted. And the controller shall have the obligation to erase the personal data without undue delay, right? The delay, I think the time that is given is 1 month. If one of a number of condition applies, undue delay is considered to be about a month. This is what I was talking about. You must also take reasonable steps to verify the person requesting erasure is actually the data subject, which means I cannot ask for a data erasure on behalf of my friend or my on behalf of my boss or on behalf of somebody whom I like or dislike based on my personal preference. So this is based on this gives citizens the right. So I, as a citizen, basically there's a PDF document. Basically, I have to fill in the details and I have to put this. I have to send this to a company based on Article 17 and Recital 65 and 66. Just as in Indian Constitution, we have these laws. So the GDPR, particularly in European Union and such things, it allows the citizen to exercise this right, which is called as right to be forgotten. Just as we say right to eat, right to practice our religion, right to, what shall I say, right to pray, worship, blah, blah, blah. They have a right to, they have given this right. Okay. Now, just, I'm not a lawyer, will not get into the legal aspects, just 2 slides here. When does the right to be forgotten apply? So can a citizen apply whenever and however you want? No. Let's say there's some private details. Can I just put a GDPR Article 17 and say no? There are certain circumstances. These circumstances is basically what I'm pulling out. The personal data is no longer necessary. The organization does not need this data, but they're unnecessarily holding on to my data. Then basically I can ask for right to be forgotten. An organization is relying on the individual's consent as the lawful basis for processing the data, and that individual withdraws their consent. They are basically relying on the individual's consent. They think or assume that there is consent, but I may not have given consent. Third point is an organization is relying on legitimate interests as a justification for processing the individual's data. The individual objects to this processing, and there is no overriding legitimate interest for the organization to continue with the process. Legitimate interest, when they say, typically it is public interest in the larger or the greater good of public. Let us say by having all these health data and such things, I'm building a model, I'm preparing a vaccination which can prevent the next wave of corona. Then basically the government, out of sympathy or basically looking at the legal merits, can still override your right to demand and say, yes, they're doing something good. They're not misusing your data. So please keep quiet. Don't disturb them. They're trying to develop a vaccine or whatever it is, the government, depending on the rules or whatever it is. The organization is processing personal data for direct marketing purposes, and the individual objects to this processing. Boss, I don't want to receive those wrong messages, direct marketing communication, and such things. I'm not comfortable with anybody. We are living in a time, basically, wherein people are very, very scared to even use their name. Typically in our tabular data, you'll have everything. You'll not have data typically, right? People, if you go to many of these social media sites, people they're not even comfortable discussing their gender or their name. They'll say big medallion, right? Isro princess, the fall guy, like this they'll use, right? They don't even want to know their, don't want people to be named. uh, they don't want their name to be displayed, right? Otherwise, there's a troll army and such things, blah, 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 right? The organization processed an individual's personal data unlawfully. So, as I said, basically, I can pay money to data vendors and they can get the data if they're connected to the hospital and such things. So, unlawfully, basically, you're taking the data, in which case, basically, I can make a request through this Article 17 saying that, boss, please delete the data. An organization must erase personal data in order to comply with the legal ruling or obligation, right? Last one, an organization has processed child's personal data. Now, this becomes serious here, correct? To offer their information, society services. So these are all some of the conditions, 7 conditions where you can apply this right to be forgotten. Now they're trying to balance this out. The company on its part basically can cite reasons and say, boss, the GDPR, right? I still want to use somebody's personal data. I'm not very comfortable to erase the data. Just because you put PDF, it does not mean that the company should, under all circumstances, respect your privacy and delete it. No, they too have their rights and such things that can trump the right. Trump means basically cancel the right to erasure. On what circumstances? The best is basically freedom of expression, right? The company can say basically, boss, I am just trying to exercise my freedom of expression and information, right? I have a right to basically take the data because, how else basically will I run my business or whatever it is? I'm not misusing it. I'm just doing some harmful marketing and whatever it is. So what's wrong with that? The data is being used to comply with a legal ruling or obligation. So whatever I'm doing, basically, I'm not selling drugs. There, I think selling drugs and such things under certain conditions is valid. But if the rules permit, basically, within this, basically, I'm doing it. Third, the company can say basically the data is being used to perform a task that is being carried out in the public interest. Look at this. He is using public interest or when exercising an organization's official authority. Public interest is the most important thing. That typically most companies defend themselves by taking the route of public interest. Then basically public health and such things. Even for public health, basically, if I have used your sensitive data, you don't have a right to demand a right to be forgotten. Then basically you can also say basically I'm performing certain preventative or occupational medicine development of drugs and such things which are beneficial to mankind. If look at this only applies when the data is being processed by a health professional. If you're a doctor and if you have a proper medical certificate and then you say for health reasons basically I'm using the data, it's available, who is subject to a legal obligation of professional secrecy. Here basically if the company or somebody says, boss, I maintain, as somebody said, masking the data, the name and such things will not be revealed. Only his demographic details, health details, and such things, BP level, blah blah blah, his heart rate and such things will be used to manufacture a drug or some whatever it is. I'm making sure that professional secrecy, utmost professional secrecy, is exercised. Then the law will rule in favor of the company. The data represents important information that serves public interest, scientific research, historical research, or statistical purposes, and where erasure of the data would likely impair or halt the progress towards the achievement. That was the goal of processing. If you say basically, boss, I'm doing this for historical research, statistical purpose, public interest, scientific innovation, and such things, there again, basically, the interest of the public basically or the larger interest basically trumps as compared to your individual privacy concerns and such things. And lastly, the data is being used for the establishment of a legal defense or in exercise of other legal claims. For legal, if I want to basically find out, let's say, I'm just giving an extreme example as to what you have done in a public restroom, right? Maybe it's a serious case of murder and rape and such things. And I am demanding CCTV footage saying that Mr. X, basically, what was he doing between 6 o'clock and 6:15? Where did he go? Typically, it's something which is bad. It is not, should not be allowed. But for legal purposes, basically, if I want to study the behavior, I can get this. So these are the reasons where the GDPR basically they trump the right to erasure, and the earlier slide basically talk about the right of an individual to demand the data be forgotten. So this is where basically the story of machine unlearning starts. Basically, GDPR and these rights. One more. So far, clear, guys? Are you able to understand what I'm speaking about? Does it make sense? Am I making sense so far?
Yes.
Now, there's a very curious problem, guys, which is called as membership inference attack. Right? There's a very curious problem which is called as membership inference attack. You may have heard of this, or you may not have heard of this. Now, this is a very, if you're an experienced hacker, then basically you know all the tricks in the book basically to inference, to arrive at an inference whether a person's data has been used or not. Correct? Let's say I want to know whether Mukesh Ambani's data has been used or not. I want to know whether Narendra Modi's data has been used or not. I want to know whether Pakistan's Parvez Musharraf or basically his army general's data has been used in some phenomena, right? I'm a hacker. I'm not, but I'm just telling you, right? So this is called as a problem, which is called as membership inference through clever questioning, wording, basically, and querying, basically. I want to find out whether a person's information is hacked, right? Is present. Now, just think of it, could be any large language model. It is not a case of direct data leakage. The model, I may not do it directly, but I'm just saying, I'm just giving an example here, okay? Boss, so I'll ask a model, ChatGPT or any of these, what is the average wealth of the top 5 billionaires in the world? This is a simple question. The question, what is the average wealth of top 5 billionaires in the world? Let's say it says hypothetically, sir, $500 billion is the wealth of top $5 billion. My second follow-up question to this first question is, boss, now remove all the Indian billionaires like Mukesh Ambani and recalculate the average. This is the question. Now ChatGPT may say $480 billion. Earlier I said basically what is the average wealth of top 5. Now I'm saying remove all the Indian billionaires like Mukesh Ambani and recalculate. It comes to, let's say, 480. 500 minus 480 is around $20 billion. Correct? Now, if you know, basically, if you do a bit of Wikipedia and something, you know that Mukesh Ambani's worth is around 200, 200, right? $20 billion. So you know that Mukesh Ambani's wealth basically has been used by GPT-3 in calculating whatever richness and whatever it is, right? What I'm just giving a very simple and straightforward example. This could be, who are the people who have stored wealth in all the Swiss bank accounts. Now, what is the approximate wealth? Remove all the Indians' wealth, right? Top 3 or 4, 5 people's wealth you remove, and then tell me what is the approximate amount. Typically, these hackers are so smart. Basically, they look at confidence score. Correct. When in after the second question, basically, how confident are you that the approximate wealth after removing Mukesh Ambani's wealth is this much? And the algorithm returns as 95 or 99% confident that 480. I've got my answer. Mukesh Ambani's wealth was used there. Are you able to understand? So this problem is what is called as membership inference attack. You'll come to know basically whether a person's data was used directly, was used or not. So, if you ask for confidence scores and output probability, and if there is a high confidence that ChatGPT reports the number, then, if there is a low confidence, then it means that perhaps you did not know. Either ways, basically, you're getting caught. So here, basically, there are strong attacks and weak attacks. Typically, when you use multiple query points or carefully crafted inputs, correct? So we are getting more into cyber attack and such things. You're exploiting the knowledge about the model architecture or the training process. See, the moment you get into model architecture, if I know that, see, most of these e-commerce platforms, basically, they make billions of dollars just through recommendation engine, YouTube and such things. They keep recommending. It need not be a pakka or a foolproof model, and they do not disclose what is the proprietary algorithm that they're using. Now, if I am somehow able to find out that they're using a ResNet algorithm with 20 hidden layers, and they have used the foundation model and they have retrained it using VGG16, what I can do is basically I can utilize this information to build a shadow model for better understanding the behavior of the target model. This shadow model basically I may use to damage their reputation or basically to degrade their sales, or if I'm a startup company, I can sell it to their competitors, and then basically I can improve, boost my sales. And secondly, basically, we are living in such a competitive world. If I don't like Netflix or Amazon or whatever it is, I can ask 500 people, maybe my own office employees, basically, and ask them saying, boss, based on this GDPR Article 17, basically, demand a right to be forgotten. Next month, basically, again 500 or 200. Now, every privacy request that you get is not a authentic request. It may not necessarily be an authentic request. So it can't be that, personal information, you're creating sensitive information, delete, delete, delete. I can't just delete blindly. So there has to be some thinking as to, should you delete everything or only some of these things? So this is called as membership inference attack. Within this, as I mentioned, basically, there are two types of attacks: stronger attack, weak attacks. Stronger attack basically is white box or rich black box. This is called as, or here in weak attack you're calling this as black box only. Strong attack is basically you're accessing the model internals, confidence scores and such things. Weak attack may be mostly the general predictions, labels and such things. Stronger attack basically there are a lot of hacking experts and such things who aim basically for high stronger attacks. Weak attacks basically lower because you're not learning much, you're not achieving much. Strong attack is less common because those companies are also smart. Basically, they have put a lot of firewalls and such things may not be easy for you to get into their internals of the algorithm. Here it is more common. Weak attacks are more common. So this is about membership attack. Now, how do you solve this basically? How do you solve this membership inference problem? So there is a solution which is called as differential privacy. What is this called? This is called as differential privacy. Now, it's a very curious technique, guys. Please tell me, somebody raise the hand.
So Mithun, when we say the probability, or can you please go back to the previous slide? Previous one. The before one, yeah. So the confidence score or output probability, is it the same as like in generative model? The
Yes,
next token predictions
yes,
probability, they go to the
yeah. That's the easiest and the
internal
simplest way.
stages and check the
Correct,
probability.
correct.
So that will be coming up through the architecture of the model.
Yes,
The weights and everything based on that will get there.
yes.
Okay.
Somebody else?
Yeah, hi Mithun. This
Yes,
side
please.
Akash.
Please tell me.
Mithun, just you have covered this weaker attacks and stronger attacks. So how come in which particular evading of filters in the LLM models, how this will be fit, whether it will be fit on the weaker attacks or stronger attacks? Like if I give you an example, like today if I write on Chat GPT, okay, give me a script where it could list all the directly and upload it to a particular server. So then it might there can be a chance that it might not give me the exactly because it will show me that it's a malicious prompt which you are asking. But if I ask the chat GPT separately, okay, give me a command, that Windows command that list the particular directory of that particular files, and in the second prompt I write this, okay, now give me the script whether it will upload to a certain server. So then there can be a chance that it will give me the particular output. So have you heard about this, or
I have not heard about this as such.
okay?
Not.
But there are some chances, right?
There is definitely, yeah. There's a
Yes.
lot of chance basically, right? Because there are so many brilliant hackers and such things who basically can inject malicious code and such things. They can pollute the data. They can pollute the model also basically at different levels. It's not so easy to stop it.
Yeah, because in the first thing, I'm giving him like a simple prompt, give me a Windows command that list all files in a directory.
Correct.
And the step two, let's suppose I am giving now, give me a command to upload a file to a server using PowerShell.
Yes,
So,
yes. You will get everything easily.
yeah, okay.
Those are all
So,
problems, yeah. We have not matured to such an extent wherein we can completely ensure privacy.
okay.
This
And
subject, when I say, yeah.
yeah, so is there any act or law like building an LLM, you should be carrying these 10 security checks? Something like that is there with any kind of law body or any act?
10 checks or any
But
number of checks, yeah, it
yeah,
could be, but I have not come across any such strong law which tells you how you have to build a LLM model. But after building a model, basically, with all these things, basically, copyrighted data, whatever it is, basically, they're quite strong in. It's mostly like a post-mortem rather than a preventive measure that we have right now.
okay, okay.
Yeah.
Thank you.
No
Thank you for
problem. No problem. Yeah.
Mithun, Vikas, one question I have. So this inference and attack that you're talking about, is it similar to prompt injection and model inference attack?
Mostly like that. Mostly that. Yes.
That's a new term. Okay. Got it.
Yes.
Mithun, I came across one of the article somewhere on internet.
Yes.
I'm not sure whether it is a correct information flowing into this internet or not. But
Yes.
someone, emotionally fooled the chat GPT by saying that his mom died and something pics etc. was on some Windows machine, and I have forgot my Windows key. Something was the story he crafted, and then ChatGPT generated some of the Windows key, and
Definitely, it is possible. It's a it's a case of very clever prompting, basically.
yes, and then that person spread out all the original or something relevant Windows key on the internet freely.
Right.
So I'm not sure whether it is a correct incident or not, but yes, I heard of it.
Yeah, even I came across this. And if you directly type, give me the steps to rob a bank, it may not give you. But if you just say, I'm writing a movie or writing a lyrics on bank robbery, can you help me with this? No, may not be so. Now they have obviously become smart. If you just describe the steps as to how you can do with some clever prompting, you can still get through their skin of ChatGPT and make it, give you answers.
Nice.
I think there will
Means we can
always
make
be such.
plans. Means money heist can be, foolproof. Not foolproof. Always somebody leaves their clue, but yes, ChatGPT could help because recently in India there is one. Sorry, India. I'm from India. So recently there was a incident that few people are watching, various videos over the Facebook and Instagram, and then they prepared a bank loot based
Oh,
on those videos. So
okay, okay.
something happened recently. It has happened by watching just videos on the Facebook.
It's possible. It's possible. Definitely, it's possible. I
I
mean,
think it's like
yeah.
even humans can be manipulated, right? So even
What is it?
uh,
Woman, na? Lumen.
human, even
Human. Okay.
assume
Yeah,
even
human. Yeah.
human can be manipulated answering certain questions. So
Oh,
even I think
easily.
machines can be done that way, and also I think it is a continuous reinforcement way that we are going to address it.
Definitely. See, there are many algorithms basically wherein if you find out 5 ways of preventing these attacks, I'll find one more exception to it, and I'll still get my job done.
Yeah, and
Prof.
one of the video that I saw is that uh, people can even train on this kind of prompts, right? So we can
Yes.
build a model which can identify the ideal prompts
Yes.
to
Yes.
manipulate the other model.
Yes. Yes. Yes.
That is a kind of malicious intent that can go against these models.
Exactly. Exactly. Okay, a lot of interesting examples. Now let's look at one thing, guys. How do you prevent this membership inference attack? Right. One strategy is basically what is called as differential privacy, which could be which could be thought of a technique to solve privacy leakage. Now, how it works is basically you add noise to query answers or model updates. You go ahead and add noise to all of those. Noise means basically deliberately you're trying to confuse the model to prevent these malicious attack. If there is a possibility that Mukesh Ambani or any of these things, their salary or health details, basically I'm trying to basically find out or source through clever questioning or querying and such things, I can add these noise. Second one is ensure that the output is almost the same whether the person is in the data set or not. You're ensuring like in the case of Mukesh Ambani, whether he's there in the data set or not, basically my output should not change drastically. My confidence score should not be so big that it becomes obvious that I'm publicizing or indicating that I've used Mukesh Ambani's salary or something. So there is a mathematical guarantee using what is called as epsilon, which is called as differential privacy, correct? So there are two concepts. One is called as differential privacy, and the second one is what is called as privacy budgeting. So this privacy budgeting is something wherein basically what we're saying is it limits the total privacy loss across queries or training. Each query or update, etc., uses only the part of budget. So, for example, if I've given you 100 rupees and you ask one query, 20 rupees gets exhausted. Next time, you ask one more query, 50 rupees. So, 50 plus 20, 70 is already exhausted. After that, I will not allow you to go further. So, differential privacy protects the individual data. Privacy budget controls privacy over time. So, just look at this. This is a very simple example. It's like a tap If you open it too much water will flow. So if you make it tight, less water will flow. So there's the epsilon, which is a mathematical mathematical notation which we use for differential privacy. Initially, it could be 0.2, correct? So 80% of the information may be leaked. I'm giving a conservative value. Then I'll increase it, let's say, some instances when it comes to money, questions related to money, health, and other matters. I'll increase the epsilon value to 30%. The remaining budget that you have is 0.5. So follow-up questions, basically, I'm penalizing. Then I'll increase it to 0.4. I stopped at 0.4, but you can increase the epsilon. Epsilon controls how much of the information is given by most of these models. So if you are basically, just to give you an example of differential privacy, let's say you are answering a survey. There's a survey about your income, but you don't want anyone to know exactly what you earn and such things, correct? So differential privacy basically adds a bit of random noise to your answers. How does it add? Basically, it tries, the goal is here again to protect your individual data, while still allowing basically analysts to get some overall trends. So your differential privacy ensures that if your data is removed, the results will not change much. So in this case, if your salary is somewhere around, let's say 50,000, the system might report something like, 48,000, anywhere between 48, the system might report 48,000 or 52,000 randomly. It knows it is 50,000, but it just, reduces it by adding some noise. So when many people respond, basically the average still accurate. Overall, the average may still be accurate, but your own personal data accuracy that your salary is 50,000 is not actually coming through anywhere, because you're reporting it as 48,000 or 52,000 deliberately, not the exact amount. Then privacy budget, as I mentioned, basically just think of it like some, pocket money or something, right? Just think of it as money. Every time the user queries the private data, they're spending some money. You put one query, basically, you lose some rights. It's like 20 rupees you have already used, or 20, 30 rupees you have already used, whatever. This privacy budget, basically, it's controlled by, as I mentioned, epsilon. Therefore, I've just given 3. It need not be 3. You can just go on. It depends upon the user, right? It limits how much of the privacy can be used. Correct. So as a typical thumb rule, if you are using small epsilon, it means more privacy and less accuracy. That is a simple thumb rule. If you give a very small conservative small epsilon, more privacy you have, more privacy means less, the answer has to be less accurate. If you use big epsilon value, basically, then it means that you'll have less privacy. The answer will be very accurate, but it's a risky. Correct. When the budget runs out, basically, after some time, basically, your budget runs out, the system just simply refuses answering, or it adds too much of noise, basically, and your answers, the accuracy is compromised in a big way. Correct. So differential privacy, just think of it like you are speaking with a voice changer. Your voice itself is changed so that nobody can recognize that it's my voice. Privacy budget, just think of it like a battery level of the voice changer, right? Each question drains the battery. So it is making, from 15%, 5%. So it does not allow you to ask very, very deep, probing personal question. The goal is still to maintain privacy. Yes, Prashant.
Can you please uh, repeat or illustrate it again? Means a little bit hard to digest this
See, what
keyword.
I'm saying is
Privacy
basically,
budget.
see, privacy budget. See, we are trying to protect the user's privacy, correct? As far as possible, I'm trying to, minimize giving out too much of your personal information. So even if you ask something like, what is Mukesh Ambani's net worth and such things, I know that's a tricky question. So algorithm at the same time, either it can say, I'm sorry, I cannot answer. Or basically it can say, instead of giving $2 billion or what, $20 billion, whatever it is, it may say something like, deliberately, it knows that it's 20, but it may approximately say, $15 billion. Right? So some noise is introduced, or it can overshoot and say $26 billion. So it is not giving you the exact amount. So
Mithun,
yeah.
I'm sorry to interrupt you. But for example, for a specific example like wealth of Ambani ji, but that data is something which is in public, right? So
Yeah, so this may be a wrong example. So something which is already in public and obvious, you don't have to do this much, right? But just think of an example which is very, very sensitive and you do not know about this. And then basically what I'm saying holds good.
So
The logic is the same,
got it.
but the example is different. That's what I'm saying.
yeah,
I
so
took up that example of Ambani. Yeah, please tell me.
but it is quite possible that person will ask the same question repeatedly, let's suppose for a week, day by day, and it will every time it will give you some. So the model will always give the approx 15 billion dollar, or sometimes it will say 15, sometimes it will say 14, sometimes 18.
It can change
Means-
basically because it does not want you to know the right number.
Exactly. So let's suppose for a continuous 1 week, I keep asking the question, and at once upon a time it says 15 and another time it is saying 18, means average I will get, okay, it is always between 18 and 15. And if
Correct.
I do some looping kind of thing for a month, let's suppose if I'm delivery want to know what a money's wealth because of some reason, so which means that after 1 month I would able to score average 18 and 19 billion dollar.
Right. See,
Is it
that's why,
correct?
yes. See, one thing here is basically that's why it is upon this large language model. You can go ahead and give this parameter, and this is what is called as privacy budgeting. How much of the private information do you want to leak or show the end user? So therefore, basically, you have a control, like a safety valve you have. How much of the information you want to leak. Therefore, there's a simple mathematical thing which is called as epsilon, which these large language model users can use. Wherein, if you want too much privacy, more privacy, you want to protect a person's privacy a lot, right? Therefore, basically, you are giving less accurate answers. So go with a small epsilon of 0.01, zero 0.1, and such things. So simple thumb rule is if you set the epsilon value as very, very tiny, you're ensuring more privacy, and hence the output that you're giving out basically will be less accurate. Sir, I want less privacy and more accurate information about somebody's information about bank details and password and such things. In that case, basically you go for a higher value of epsilon. So the bigger the value of epsilon, it means that you have less privacy. Less privacy means all of your private details and such things basically will be shown outside, and therefore less privacy automatically means more accuracy, but it's a risky proposition. So your epsilon basically is used. It's just a terminology. You can set it between 0 and 1. How much of the private information do you want to show? That's what I'm saying.
Yeah, is there any relation between epsilon used in remaining budget? Let's suppose if whatever you are showing on the screen, if
Yes,
I have
yes.
to add it, the first one will come up as 1, but the next one will come as 0.8 and the next one is 0.6. Is there any correlation between these
Yes,
two?
yes. As you go on, this is like money, right? If you spend too much of money, basically, it's like 100. I've given you a cap of 100. You can't spend more than 100. So if you are basically asking a very private question, right? Your 40 rupees is used up, let's say. Next time you ask, basically 50 rupees is used. Third, basically, you can't ask so much of private questions, basically, because you have balance only 10.
Sorry, come again. Sorry.
So what I'm saying is basically use epsilon as a controller. And as you basically use less value of epsilon, smaller value of epsilon, basically, you're protecting privacy. But how are you protecting privacy? By giving less accurate information. And to your question, is there a relationship between epsilon and remaining budget? Yes. So because typically when you add up epsilon and budgeting, right, it'll add up to 100%. So more epsilon value you use, lesser the value of budget you'll have. Remaining budget will go down.
Okay.
Right?
So this epsilon is like it corresponds to a particular query, right? For each query,
Yes,
there
yes,
would be
yes,
a
yes,
particular epsilon.
yes,
So for
yes.
sensitive questions, the epsilon would be
Higher or lower, depending on how much you want the end user to learn.
okay. And this we are using it because even the model is being trained on sensitive data that
Exactly,
we would
exactly.
not be knowing.
Correct. So that's why it's called as differential privacy. Different means different values of private information I'm showing.
So how is this epsilon like assigned to each query? Is it like, is there some mechanism?
Yes, see, for certain categories, basically, let's say for certain categories and such things, basically, you can give a very, very aggressive epsilon. For certain other categories of questions, basically, maybe you can train and give a smaller value of epsilon. If it's a harmless thing, and maybe if it is about privacy and such things, and I don't see too much of misuse, potential misuse and such things, and I'm okay with giving accurate answers. What do I do? What do I do? Big epsilon. If I'm very, very cautious, people's income, health, and such things, not so sure, I will make the I will make the epsilon very small.
Okay.
Categorize your queries, basically.
If I
So
have
also
to
like queries, we have to do some kind of training of a model
Yes,
to
yes.
categorize whether it is highly
And your,
sensitive or not,
yes,
and then
exactly.
use this epsilon accordingly.
Exactly. Yes, yes.
if I
So
have
with
created a fourth column here, query epsilon used remaining budget, and fourth column as a total budget. So what would be the value in that column?
Typically, let's say it's 100. It should come up to 100.
100 or 1?
One, because it's in decimals. If it is in decimals, it will be 1. If it is absolute
Okay.
numbers, it'll come to 100.
Okay.
Yes.
So Mithun, if I'm understand correctly, not sure, like I got that because a little confused. So when we say an end user is querying any sensitive data, if we have epsilon is lower, then the algorithm will restrict with the information. Is it true?
Yes. Smaller the value of epsilon, more
Okay.
privacy you will have. More
So
privacy you have, therefore the
when we say
end
more
result will be less accurate. The
So
final
when we
answer will be
say
less accurate.
more privacy, is it we are providing? I mean, we are training to algorithm that okay, this is more privacy, so the answer.
Answer you should be less accurate.
Okay, okay. So it
Smaller
is
epsilon, always less accurate answers. And it
okay.
guarantees more privacy. Bigger epsilon, basically, you'll have more accuracy, but risky and less privacy.
So and do we have any formula to categorize this or like?
It is simple thumb rule. It is.
Okay, okay.
Okay.
Mithun, why don't we use machine unlearning? Because I think privacy was one of the major use case when you explained about that concept.
Yes.
So with this differential privacy, what we are trying to do, we are trying to make sure that model should not expose the
Privacy details. Yes. Yes. So here, basically, these are all techniques. So machine learning is a big science. I'll just cover some of these techniques or
understand.
strategies. This is one of the many strategies.
So one of the strategy to implement machine
Yes.
unlearning.
Yes. Yes. All of these things come under machine learning itself.
Thanks.
I think one of the point that you mentioned earlier, if the training data that we want to unlearn, if it captures some of the important patterns or important in like it is spread across multiple important nodes which are impacting lot of weights, then if we completely remove them through unlearning, it would affect the model. So this kind of sensitivity adjusting this would do better, right?
Yes. 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 Definitely. Right. There I can say, boss, I've made sure that I've taken extreme care to the legal compliance team. I've taken extreme care to protect people's privacy through all of these measures. One of the challenges here is that models may forget too much, right? So typically, when you want the model to forget, I want the model to forget, but it may forget too much. There is no lack of, there is no industry-wide tool to evaluate the effectiveness of unlearning, right? In learning, machine learning, you can use your F1 score, R square, this, that, mean absolute error, MAPE. Here, sir, can you mathematically prove and tell me, sir, that your strategies have worked? The mathematics might not mathematically to give you a rigorous proof which establishes that this strategy has worked 100%. That's a bit of a problem here. So larger models can generate more toxic, hateful language and contain sensitive data that defy cybersecurity standards. So typically, right, wherever you're sourcing unstructured and untrusted data from the internet, there basically you'll have privacy demands sooner rather than later. Rigorous attempts should be made to filter the data. Remember, guys, retraining we are trying to avoid as much as possible, because to remove the undesirable data, it takes months and costs millions of dollars. And retraining is not an option. So if you're doing retraining, well and good. For small data, you can do it. But for large language models, we try our best not to retrain, because you have to retrain from the scratch and it is cost intensive. Typically, all of your open source models, if there's an open source model from Hugging Face and such things, privacy and such things are basically compromised. And the vulnerabilities in the base model, I'm taking the base model and just tweaking one of the layers of the neural network, but the foundation model may still have corruption, which will reflect in my model as well, right? So open source models and such things, basically, in other words, he's saying basically all of these things are risky, and if you want privacy, avoid this. Now, when it comes to unlearning and such things, guys, there are three broad approaches. One is what is called as naive retraining. Naive retraining basically means it's like a baseline. This is the strongest guarantee that the data's influence is gone. Correct inefficiency, because I told you, you have to start from the scratch. High computation is power is required. And imagine if you have to retrain the entire large language model, it is, it's not so easy. The other extreme is what? Exact unlearning. Exact unlearning is what it provides the strongest guarantee that those data points which have demanded privacy, you're removing. For privacy and legal compliance, basically, you can hope for exact unlearning. This is considered as a gold standard, and it involves methods for perfect removal. Right? Approximate unlearning. Mostly, basically, we are in a stage of approximate unlearning, not exact unlearning, because it is practically possible, right? There is a saying in English which my professors used to say, it's always good to be perfect in life, but never allow perfect to be the enemy of good. If you have a good solution, that's fine. But if you aim for perfection, basically, exact unlearning, if I have to do, I'm trying a lot of things basically to remove 1 or 2 or 20 people's data points. I may be spending too much time and all the, we should not, there's a saying, one more saying basically, you should not never make the mistake of throwing the baby with the bathwater. Right? You want to throw the bathwater, that's fine. If you throw the baby also, baby is something which is useful. The essential ingredients we don't want to lose while we are trying to unlearn. So that is a typical strategy that we use. So remember, naive retraining is that this is the baseline model. Exact unlearning, very good, but may not be pragmatic. Approximate unlearning is what we try to follow. Right? So machine unlearning techniques, guys, you can see there are quite a few machine unlearning techniques, not one or two, but there are all of this. This slide itself basically talks about you know or different unlearning techniques. Now, which of these unlearning techniques should we use? Which of these unlearning techniques should I not use? That is the question. Now, typically what happens is, all of your strategies that you look at this from top to bottom, guys, you have database strategies, and these are architecture-based strategy, and this is what is called as federated unlearning. See, under database strategies, you have certain algorithms like BadNet algorithm is there. Then you have what is called as class clown and mnemonic codes. Under architecture-based algorithm, this is further divided into modular unlearning, gradient ascent, teacher-student unlearning methods, and then you have scrubbing weight approach. And here you have the last thing, which is called as federated unlearning. I'll just talk you through some of these things, guys. Just remember, database techniques basically typically when we say BadNet or class clown or mnemonic code, these methods insert or erase specific patterns in the training data. For example, if a model has been trained to recognize fruits and you want to remove all the images of the apples so that the model only forgets apples, you can use this method. Then there is something called as fast yet effective machine unlearning. As the name itself suggests, these are very quick, dirty methods to make the model forget data without retraining anything. I'm not retraining anything. Very quick fixes, basically. Example, if you want to remove a user's name and details from a chatbot's memory, then perhaps this method is useful. Then you have architecture-based techniques, guys. Here you have modular untraining, unlearning, gradient ascent. You have teacher-student method. Then you have a certain scrubbing weights approach. I'll just speak about one method, guys, which is called a CISA. There are others as well. One method I'll just speak, which is CISA. This is something which you should know. Then there is something called as gradient ascent. You might have heard of gradient descent. This method is called as gradient ascent because it is gradient descent means dy by dx, derivative of y with respect to x, which means you're trying to learn. Gradient ascent means basically you are unlearning that. So if upon differentiation, if I get a plus sign, it means I'm learning something. Gradient ascent is basically undo using some reverse is mathematical jugaad. If there is a plus sign, you do negation so that it cancels the learning part. So this is called as gradient ascent. Teacher student method, teacher student bad teaching, these are all some of the algorithms. The student learns from the teacher but with filter knowledge, which means basically a tutor only the teacher teaches only part of the syllabus, not the entire syllabus. It's like that. Now, the most important thing is CISA, which I'll talk about. But before that, there's a concept which is called as federated learning, guys. In the case of federated learning, what happens is, see, typically what happens is you may have your devices like phone, smartwatch, and such things, from which basically you take the data, you send it to the server. The moment the data leaves your device, basically data is compromised. What happens in the case of federated learning is that you are not allowing the data from the phone or smartwatch to basically leave the device to the server. What you're doing is you're using federated learning. This federated learning basically allows the model to be trained right on the device, which means I'm sending the model to the phone so that the data from the phone is in the data, it is in the phone itself. The model gets trained on the device. The device trains only on that piece of the model. Then basically the server then updates all the learnings and such things basically, but I'm not allowing the data to leave the system. So this is what happens in federated learning. Just remember, federated learning is all about, model training happens locally on the device. That's the beauty of it. It keeps all the sensitive data on your device itself so that the data is not going out of the system. Is that clear, guys? Yes, please. Yes. Yes, please.
Regarding gradient ascent, is it
Yes.
same as like
Is it same as? Hello? Hello?
we are taking a negation of?
Yes, use
Can
the
you hear
opposite
me?
sign. Use the opposite sign. Correct. See, gradient descent is used for machine learning, correct? You
Yeah,
differentiate it, and let's say some stages basically you get plus, correct? Now
yeah.
basically you want to unlearn it, use a minus. So basically
Okay.
the model is behaving like, wherever there is a plus sign for certain cases, it is assigning a negative case. So those cases which were used now basically those, let's say there are there are 200 cases basically wherein people have asked for privacy. What I'm going to do basically, I'm going to look at the data in the training stage for these, let's say 200 cases. The dy by dx was positive 2, positive 2, or positive 2.5. Now I want it to de-learn, remove the learning. What do I do? Minus 2 I will do. So the model
Yeah.
is getting confused basically. Next time, basically, I have made sure that I've canceled the learning, right? If
Okay.
you're taking if you think, okay, by taking 20 steps and then taking a right turn, I may reach my home, correct? Now, basically, you're walking backwards in the opposite side so that you remove that learning, right? That's how it works.
Okay. So it's like again training
Ulta.
on a like new set of data, which is like exactly opposite to the previous data, like
Exactly.
negation of
Exactly.
those statements.
Exactly. Now, I'll just speak about one concept, guys, which you should know, and that is the takeaway for you, which is called a CSAP original. This is one concept. If you know this, practically most of this entire machine learning basically runs on this CSAP. By and large, 80 to 90% of the work is done on CSAP. For others, basically, I can just give you some reading material, right? It is CISA, right? Now, CISA, what is this CISA? CISA is a technique, guys. Okay. This is perfect unlearning without retraining. Okay, a big reduction you can expect in computation time as compared to naive retraining. So it has a lot of benefits. Its effectiveness depends upon the different algorithms. Disadvantages, I'll tell you about the disadvantages, but let's understand CISA as a problem, right? these are use cases. I'll go to CISA. CISA basically stands for sharded, S for sharded, isolated, sliced, and aggregated. So this is what it means. AKA, it's also known as the only exact unlearning technique for deep neural networks so far. There's no other technique to beat CISA so far. So just imagine, guys, you have a set of data. You have, let's say, like this, 3, 4, 6, 6 threes are 18. This is their input data set. What CISA does is, let's say there may be 2 or 3 records basically which are polluting. What you do is basically first step is basically you shard, which means basically you break the data set into 3 parts. Here in the diagram it is 3. You can make 30 or 300 or 400 parts. It's up to you. So break the data. Then for each shard, basically you start slicing the data like this. So you have a shard, you have started slicing the data set. Now, this shard or part of the data is fed into the deep neural network. So each of these diagrams that you see, that is nothing but a submodel which has been trained on one shard and one slice. So eventually, when you look at it, guys, you can see here, you have, I'll just go back to this and just explain this. Let's say you have one big gunny bag of 1,000 apples, and you suspect that there are 2 apples which are rotten, which have become polluted. Now, as an outsider, you do not know whether it is 20 or 2 or 3 or 4. You are not very sure about that. Then what are you basically thinking? You're thinking basically, how do I contain these 2 points, right? So these 2 points basically can be contained. Originally, I began by saying you have a big gunny bag. So take 500 packets, plastic covers, put 2 apples in each of these packets. Correct. So when you put two apples in each of the packet, what is happening basically? The rotten apples may come in 1 or 2 packets only, because you have 500 small plastic covers. The 2 rotten apples basically may come in 2 plastic covers. So the balance 498 plastic covers basically anybody can use. Basically, there is no problem. So what I'm doing is the effect basically I'm containing in a localized packet. It is localized. Now, is the entire apple rotten? No, only the part of the apple baby may be rotten. So firstly, shard, those 500 packets which I was speaking about, those are nothing but the shards. You take the apple and further slice out, basically make 4 slices. The rotten part may further go out. So what you're doing basically with this architecture is that maybe the effect or the influence of that data point, basically you're localizing it basically so that the overall value, the overall impact is basically contained to a very, very small extent. Just think of it. You're using slice 1 in epoch 1 and epoch 2. The epoch 1, let's say you're just doing a machine learning model, and you have slice 1, you have epoch 1 and epoch 2. Then you checkpoint this, which means the learning from slice 1 that you got, you're checkpointing. And then you take it to epoch 3. In epoch 3, basically, you're putting slice 1 and slice 2. Epoch 3 and 4. Again, you save the learning. So progressively, you go on checkpointing. Then you have epoch 5, basically, wherein you have slice 1, slice 2, slice 3. You have epoch 5 and epoch 6. And then basically you're building the final model. At any stage, basically, if you feel that one particular slice or one particular shard basically needs to be removed, correct? That can be removed because before the checkpoint, like let's say in slice 2, basically, if you feel that your slice 1 has to be removed, correct? Slice 2 you have introduced at this stage, you have to just go back to the learning after the first checkpoint. Slice 2 basically you introduced at this stage, so you have to go back and de-learn from this stage onwards. That's how you basically go ahead. Did you understand this, guys? CISA framework, guys? Did you understand the CISA
Do
framework,
we
guys?
do
Everybody?
we
Yes,
like
perfectly.
evaluate
Yes.
after? Do we evaluate at this checkpoint to see whether it is good or not, and then do?
No, first basically, see, the CISA is basically is it's all about data partitioning, basically, right? How you are partitioning the data into shards. These are the shards, and then basically slices. Once you partition the entire data into shards and slices, and then feed the slices into the model, at any stage, basically, if you see, I do not want to know, let's say I do not want to know Mukesh's information. Let us say through this, I may come to the conclusion that Mukesh's data has been introduced in epoch number 4. So till here, basically, I will not take, I will just break the neural network here and take the learning from the other data points.
So it's more like a incremental learning, yeah?
Yes, incremental checkpointing, and because of that incremental checkpointing, wherein I'm saving the learning at each stage. At whichever stage, basically, I realize that somebody's private information has been introduced. At that stage, I will make an intervention and remove that.
But in this
So
process,
is
we
it
can
like
lose the good data also, because
See,
the slices coming with some
have,
necessary data also, yeah?
yeah, see, just take a look at this. If there are 500 shards I make, I go back to that example of gunny bag wherein you have 1,000 apples. I am making it into 500 packets. 500 into 2 is 1,000, right? In one packet, if there is a bad apple or a rotten apple, and that I'm feeding into the submodel, remaining 499 or 498 data sets basically are unaffected, right? So it is like putting one drop of poison in Pacific Ocean, right? And therefore, basically, you can still hope to get better results with this.
Okay, got it.
and is that data like masked? Can we don't know, right? Which
We don't
one?
know. We don't know. We see. Typically, if you have already done masking and such things, it may not come to such a stage, because that itself is an answer for you to say, boss, I've ensured privacy.
Yeah.
Correct. You
So
don't
we
have
have
to.
to kind of evaluate somewhere at each of the checkpoints to see whether
Yes.
we have to remove or not.
Yes. Yeah. Were you able to understand this, guys? Everybody.
Yes,
Yeah.
yes,
So
definitely. Yes.
you are building multiple submodels, right? So these are all submodels, which means 500 submodels you're building, 500 large language models. Out of this, one of the submodels which is fed the wrong data may be corrupted. So you have to tweak only one of the submodels. The remaining 499 you can still operate and implement. There's no problem at all. So I'm marginalizing it, isolating it, and then basically reducing the impact of that bad data point, or those people whose privacy needs to be protected or whatever it is. I'm removing their influence from the rest of the 499 shards. That's what it means. Did you get this, guys?
Yes, yes.
So this is size CISA basically. So remember this, does CISA have a special impact on imbalanced data set? Yes, it does have an impact. So it's one example basically, guys. So 0, 1, 2, have you come across this data set called as MNIST data set? Handwritten digits. Have you used any time?
No.
No, just remember this, it will be taught to you at some stage. So people have given handwritten images. So somebody can write 0 like this, somebody can write 1 like this, 2, 3, 4, 5, 6, 7, 8 like this. Okay. So if this is 0, this is a minority class. Majority is what? The blue, non-zeros. It's like, in healthcare, COVID affected people are what? 1. Unaffected people are what? Maybe 1 million. So this is what we call as class imbalance. So look at, for 1, there is class imbalance because look at the height of the small blue part. It is very tiny. For the others, basically, you have the majority class. The blue part is the majority class, and the handwritten image is basically the minority class. Now here, the ratio may be 1 is to 10. For one of this handwritten image, you have 10 cases which are not 1. Here, basically, we are making it the ratio as 1 is to 100, and here it is 1 is to 1000. The main point of what we are trying to say is, what do you expect basically? Y-axis is basically error. And if you were to train it on different classes, 1 is to 10 ratio, you feed it into the CISA model, 1 is to 100, 1 is to 1000. You're monitoring the error rate, right? Typically, what you expect, if there's a 3% error in the majority class, consistently it should be 3% everywhere, irrespective of the class imbalance. But what you actually get is, when the class has an imbalance of 1 is to 10, you get 91% inaccuracy using the CISA model. If the class is basically, which means 1 COVID infected, 10 healthy patient, if you take in the ratio, 91% error you will get. If you take it as 1 is to 100, 183% error you will get. If you take it as 1 is to 1000, 100% of this will be misclassified. Are you able to get this?
No, can you
Mithun,
explain again, Mithun?
can you please repeat this?
See, I'm just telling you what is the performance of the model, especially when there's class imbalance. Do you understand the problem of class imbalance?
Yes.
What is class imbalance?
Class imbalance is when one set of data has more data points as compared to other data.
Absolutely, absolutely. Like COVID infected and healthy people, 1:1 million. If you have one person is infected, the remaining 1,000 cases may be uninfected. So if you train this in a model, what will happen basically? Typically, the dominant class is healthy people. The model will get trained on healthy people, not on infected. It is doing exactly opposite of what you wanted to do. You wanted to learn the behavior of infected people. It will learn the behavior of uninfected people. That's the problem. So you have it like this. When you have it like this, sorry, right. So yeah, just take a look at this. When you have 1:10, 1:100. So this is a research basically. If you have the class imbalance in the ratio of 1:10, what happens? What happens to the error? Error is nothing but 1 minus accuracy. If you have 1:100, what happens? 1:1000, what happens? That is what we are interested in seeing. What do I expect basically? Typically, irrespective of the class imbalance, I may expect an error rate of 3%. There must be a 3% misclassification for each of the cases. But when you're using a CISA model, what do you get is basically the error. This number that you see is nothing but the error rate. If you have a class imbalance of 1:10, 91% error you have. If you have a imbalance of 1:100, 183% error you will get. And if you have an imbalance of 1:1000, 100% error, which means all of your classes will be misclassified. So I'm using this to say that CISA models or framework basically are affected by class imbalance to a large extent. That is the point. Is this understood?
But like, how does this relate to the exact unlearning? Exact unlearning is something that we are trying to remove the effect of some kind of training part. How
Through
this is,
CISA, right? See,
yeah.
that part is over. The CISA part basically takes care of basically through sharding, slicing, isolating, whatever it is basically. Sharding, isolating, slicing, and aggregation. I'm removing the impact of one or two data points. That part is over. CISA takes care of that. Correct? I'm containing or mitigating the effect of that bad data point through this sequence of data
Okay.
steps.
So when we are removing such
Aha.
data points, in case of imbalanced data,
What happens? That's what I'm saying.
okay.
So this is a property of the CISA model, this is a property of the CISA model, which I'm trying to explain.
Okay. Okay, got it.
Okay. Did you understand this, guys?
Yes, slowly capturing.
What are you saying? Only capturing.
Yes, slowly we are getting that.
Okay. Just remember CISA, guys. Just want to show you one example. See, are you able to see my screen? One example, I'll just quickly show you.
Yeah.
Just have a look at this. So this is a typical breast cancer data, this thing model, right? What I'm doing is basically this is a usual package in Python, which I'm trying to install, load the breast cancer data set, so on and so forth. And I'm just displaying the data. What is the radius, I think, of the clump or the tumor, texture, perimeter, mean area, mean smoothness, compactness, concavity. And somewhere here I have, whether it has been class. Look at this. This is the target, whether it is tumorous or not. Correct. I'm just showing you how we can unlearn. This is a small example as to how you can go ahead and unlearn. Just take a look at this. You're splitting the data into training and test. There's nothing new about it. You might have learned about this X and Y you do. You'll get X train, X test, Y train, Y test. Now you're training the model on the full model. There is no deletion, there is nothing. Model underscore full is training on the entire data. You're choosing, this is one phase of it. Till here, you have understood training the logistic regression model.
Yes.
Now comes the phase of unlearning, wherein I'm just choosing to delete one record. Let's say somebody has requested for privacy, or let's say 2 or 3 people or whatever it is. So delete underscore index. So the first row I want to delete. So I'm going to use the function np.delete from x underscore train. I'm going to delete the index. Axis is equal to 0 means row wise I'm going to delete, and I'm going to create x underscore train underscore new. Underscore new means what? I'm trying to tell you that this is the data of the independent variables after deletion. Similarly, y underscore train underscore new after deletion, np.delete command I'm using. After deletion, what happens here? As a test case, I've just taken one example. You can choose to delete 10, 15, or 20 cases. You can go ahead and delete. Now, what are you going to do here? You're retraining after deleting one sample. So this is a case, basically, you can see here, a model underscore retrain dot fit. The only change is basically after deletion for the new independent and dependent variable, you are going to go ahead and retrain, correct? You can store the accuracy. You can see here, I'm writing this as ACC underscore retrain. So there are three approaches. One is on the full model, I'm building the model. Second one is I'm deleting a few records and then I'm going to build the model. Then I'm going to show you one small example of approximate unlearning, correct? Approximate means near unlearning, may not be exact unlearning. So here we are using a gradient based idea, which is understanding the real influential function, understanding which are the points which are influential, then go ahead and remove it. So for this, what I'll do is I'll just show you one small example. Not this. Can you see this, guys, everybody?
Yeah.
Yeah.
Influence function approximation. So there is a technique which is called as understanding the influence of the data points. If those if those people who have requested for privacy, what is their influence on the overall model? If it is having too much of influence, then go ahead and remove it, or else basically ignore it. So influence function comes to our point. Now here, if we remove one data point, we can estimate its impact on the model parameters without retraining. So whoever data point you're removing, you have to understand its impact on what? Model parameters. Model parameters means what? All your beta coefficients and such things. Theoretically, there is a formula. What is that formula? See, this is the formula. That is, you take the old value, correct, minus H inverse. H inverse is nothing but your Hessian matrix is there. You have to find the inverse of this matrix inverse, and then basically you are doing the gradient of the loss from the deleted point. You can see here x del and y del. This delta L is nothing but gradient of the loss from the deleted point. So you are finding out the gradient, multiplying it by the inverse of the Hessian matrix. What is the inverse of the Hessian matrix? It is nothing but the second derivative of the loss function. You take the derivative, upon that one more time you take the derivative, you will get H inverse. You multiply these two from the theta old value, you subtract these two components, you will get the new parameters. So this is what can be used as new values. And once you can use these as new values, you can go ahead and, unlearn. So this is the formula that we are using for the unlearning part. So the last part is approximate unlearning. This is the approximate unlearning using simple gradient based idea. That is the influence style, which I've just now spoken. Just have a look at this. X underscore train, Y underscore train for the deleted index. That's what you're doing. You can see here, this is the, please go on mute. Please go on mute. Somebody, please go on mute. Correct. I'm calculating. Have a look at this. Correct. I'm calculating the probability values as well as the gradient based on the formula which I just now showed. And in the last step, what I'm doing is basically simulate the parameter update, approximate inverse Hessian effect. So this is just a case wherein I'm building the model. This logistic regression function, I'm calling it as it is approximate coefficients. Basically, you can just recall model underscore full dot intercept, model underscore full dot classes, model underscore approximate model. That is after subtracting the effect. You can see here there are three parameters. Accuracy underscore full, you're getting 95%. For the retrained model also, approximately in this data, you're getting 95%. Accuracy, which is approximate learning, you're getting 89%, which is almost like a 6% drop. Are you able to get this, guys? There's some project idea if you want to explore this further, right? Can you see this screen? Can you see my screen?
Yes.
Correct.
Yeah.
Just see here some of these projects, right? Unlearning in a spam detection, correct? Let's say you're trying to build a spam classifier, right? Then remove wrongly labeled spam emails and evaluate how unlearning affects the model performance. This could be one project idea that you can take. Correct? Removing a bias sample in MNIST. So you're removing the effect of a bias sample. Let's say you're training a digit classifier that is 1, 2, 3, 4, 5, 6 handwritten, somebody has written. Then remove all the instances of a specific digit, that is 5 you are trying to remove, and applying the unlearning methods. Correct? You can study the model bias and accuracy drop. Now, the third one is basically you can unlearn, you can also do some unlearning from hate speech tweets. Let's say you have a Twitter classification data. You use a tweet classification model and identify and remove offensive tweets via unlearning to improve the model ethics. Fourth is basically patient data privacy in health records. Train a health condition classifier, correct? Then remove a GDPR right to forgot by unlearning. So just, whosever cases basically you want to unlearn, that is something which you can learn. I'll just show you one quick example, guys. Maybe you can just understand this. A small example. Are you able to see my screen?
Yeah.
Just a simple data, which is of car sales. Okay, you have sales model and you have resale type of the vehicle, and let's say you have price, engine size, horsepower, wheelbase, width, all the vehicle characteristics are given. I'm just going to show you one simple way in which you can remove the influence. You have learned linear regression, go to linear. Let's say you can choose all of these variables. Some of these variables you can choose as the independent variable. Then dependent variable is log transform sales. You have to just choose this log transform sales. Now, what are you going to do here? Basically, you can go to the save button. Here, just look at Cook's value and Leverage value. What are these? Basically, they are trying to help you identify influential points. So just uh, choose this, continue, and then okay. Okay, you are getting all these coefficient values here, beta coefficient, that's fine. But interestingly, in the data set, what has happened is basically, I've created new columns, which is Cook's value as well as Leverage value. Correct? Cook's value is there, Leverage value. There are two things that you can do. Go to a graph and say chart builder. Do a simple scatter plot here. So you have the Cook's distance and you have the centered Leverage. I want to label one point as well based on the model of the car. Correct? Click on OK. Can you see this, guys? This is a model which I've built. In the y-axis, I've taken what is called as Cook's distance, and the x-axis, I've taken centered Leverage value. See, most of the values are clustered in this region. But look at this, 3000 GT. This is one of the model of the vehicles. It is very, very far. And why is it far? Because the Cook's distance value is so high for this. Correct. Now here also for metro, also you can see both Cook's distance as well as Leverage value. These are just KPIs. Like, how do you find out whether a person's low BP and high BP may be very high, dangerous case. The same way, just as you have low BP and high BP, for identifying influential points in regression, you have Cook's distance and centered Leverage value. So 3000 GT is a very, very large value of Cook's. Metro, basically, you have both high value for Cooks as well as centered Leverage value. Leverage value is also high. Viper is also high. So these three cases basically have high value. So you may ask me, so what? So I'll just tell you one thumb rule, basically. Can you see this, guys? Can you see this? Are you able to see this?
Yes.
Yes.
Just look at this Cook's distance. First thing, this is the KPI. It identifies observation that influence the overall fitted value significantly. Typically, if it is above 0.5, moderate impact it has. Above 1 means it has high influence. So high Cook's value suggests that the observation affects the predicted values. Your predictions and such things go wrong because of high Cook's value. Investigate these cases for potential unlearning. So wherever you have a value of either greater than 0.5 or greater than 1, you have to investigate these for potential unlearning. So this is one way in which you can do machine unlearning. Next is average value. It measures how far a data point's predicted value deviate from the mean of all the predictors. So this is a simple formula. Don't worry about the formula at this stage. Now, what does a high average point indicate? It can impact the model disproportionately when combined with high residuals. So that is fine. Now, what is the takeaway for you basically? Just look at this from machine unlearning. It identifies points whose removal would meaningfully change the model. So this is a case of approximate unlearning. How do you do it? If the Cook's value and DF difference in beta are high, then the point, have a look at this, then the point is a strong candidate for approximate unlearning. So wherever, just keep this thumb rule in mind, wherever you have a high value of Cook's D, that is a strong candidate for your unlearning. Sir, how do I find this out? Just come back to this original data. You have the Cook's value, right click and sort it in descending order. So you can see here all these values, the first three cases 0.22, 0.16 and 0.14. In the scatter plot also you saw that they had a high Cook's value, which means that it is a candidate for unlearning. Sir, are you not being strict? Yes, I'm being strict here. Typically, you can use any value which is greater than 0.5 for unlearning using the Cook's distance method. Are you able to understand this, guys?
But this is usually for regression only, right? Regression models.
Mostly for regression and regression-based models.
And also, these are like in regression models, we are going based on kind of outlier or something which is more impacting, which
Yes.
is out from standard behavior, which are more impacting.
Yes. Mostly it's a regression-based measure. Anyway, I've told you CISA. If you use CISA algorithm, guys, you should be able to, you should be able to tackle 90% of all the machine unlearning problems. There are two very good research papers, guys. These are the two research papers you can see here. A systematic literature review of machine unlearning techniques in neural network. Right? For deep neural network, always use CISA. As of now, that is the established gold standard. If that also you are able to understand and take away, that's fine. Machine unlearning, what are the solutions and challenges? There are a lot of Chinese people who have written this. Ji Shu and Zihan Wu. These two papers also, if you read, you should be able to get a good understanding of machine unlearning. Did you understand this?
Midun, can you please share that the last issue you mentioned, right, about publishers things?
The PDF you want?
Yeah,
I can share the PDF. You want me to share now or later?
yeah, you can share it here also.
Okay. Now we can do this. We can, I've shared it in the chat window here. Any questions, guys? Anything you want to ask me?
So Mithun,
Yes, Mithun, I have
like
to. Sorry. Yeah, Venkat, go on. Then I'll ask.
yeah, so thanks. So one of my thoughts after this is like usually when we train the model or like even when there is drift or something, like we continuously keep training the model with more amounts of data, right? Suppose
And
in case of where we observe that there is some kind of data drift, in that case, instead of unlearning, we could kind of train the model with the newer data, which is more uh, appropriate, and then it would naturally be more inclined towards that. And if that in a way kind of negates the previous one, it would obviously shift towards the newer context of the data. So that
yes,
is kind of comes under the ascent uh, that category that was there, right? Ascent
yes.
learning,
Gradient ascent, yes.
gradient ascent.
Yes.
So if gradient ascent is would be fine, like it would work fine, then the exact unlearning would not be such a attractive
Yes.
subfield going forward, right?
See, you can use machine unlearning if somebody, as per the GDPR, or basically whatever that rules, basically Article 16, 17, whatever it is, as per that, basically he has requested a right to be forgotten. That basically is the starting point for your machine unlearning rule, right? Now, what you're talking about, this Cook's distance and such things which I showed you, basically, there is mostly a category wherein you're fine-tuning the performance of the model. Are you getting it? Now, one of the framework under machine unlearning is SISA, SISA, which I showed you: sharding, isolating, slicing, and then basically building the model, right? SISA. So these 3 points, if you are clear, then I think it is a good beginning. Understood?
Yeah.
Yes.
Okay. So, Mithun, my question is, are the industry, I mean, the major LLMs are planning to inject this in their pipeline, this CISA algorithm and etc. Let's suppose in future GPT-6 or it will come up, and that will have these things already inbuilt, so that we don't have to revisit all those things again in the future LLMs, because so far it was not matured, but you are saying that yes, this CISA is the matured one. So are there is a industries planning to inject in their pipeline? First question. Second is, if CISA is already there, the formulas were there, the delta and the epsilon was there, then why they have not considered it while building this LLM?
See,
So
all of
this is
the,
my
yeah.
first question, and then I'll ask the second one after you answer it.
Okay, see, first one is basically, are there any implementation? I could not cover all of these things. Just one use case I'll just show you. Team of researchers from Microsoft, basically, they have used this basically for Meta's Llama 27B. I hope you can see this. Are you able to see this?
Yes, yes.
Yes, yes.
See, the goal was to forget the copyrighted material from Harry Potter, right? I think while training this Meta's Llama, basically, they use this copyrighted material also from Harry Potter, which has been trained on from the internet. Anything which comes from the internet, basically, it will surely at some stage you'll have to flush it out. So before unlearning, basically, if you were to write who is Harry Potter, the model typically would give a response. Harry Potter is the main protagonist in J.K. Rowling's series of fantasy novels. Now, after unlearning this, basically, your Harry Potter, the response that the model gives, the meta model gives, basically, is Harry Potter is a British actor, writer, and director. So once you strip it of its context, what happens? What is the conclusion? Every time the model encounters a context related to the target data, it forgets the original content. So the short answer to your question is, Microsoft has already implemented this. Then IBM also basically has implemented it. They have come up with their own framework, which is called a Sponge, SPUNG. Just check that out. SPUNG, how they splice, then basically, and then merge. So they have given a fancy name, Splunge. So, that model which IBM has implemented is called as Arcane, ARCANE. Is that clear?
Yes, now clear. And second question is means that's not related to the content, just related to your experience. When you started taking our master class, you mentioned that yes, the artificial intelligence or machine learning is not a Q. It's not a new word in the industry. It has been existed since last 30 years already.
Yes.
But and today you started it with the keyword that the machine unlearning is a new fancy word is coming into the system. It's not so mature or something. So based on your experience, whatever you have, 10 year 20 years, when you first heard this machine unlearning thing, and what's your take on this? Means we partially discussed, but just I want to
You're right.
uh,
See,
see your view.
I first heard about this in 2021 when one of my students basically sought help. She was doing a paper on machine unlearning. I did not take it seriously. She said that her PhD research itself was in machine unlearning. So I took one more fancy terminology. Every day somebody comes in and publishes something. Why should I take it seriously? Then basically, as I interacted a couple of times, I felt that it has a lot of potential. Now, when I look at it in the context of these regulations, GDPR regulations and such things, and maybe we in India, basically the discussion has not matured to such an extent wherein we take privacy and such things seriously. Correct. But there, these laws basically have to be respected. And therefore, machine unlearning, basically the starting point, the mother of machine unlearning is that GDPR, all those laws. So we are discussing a highly futuristic subject. Whatever I'm talking about today, maybe 5 years or 6 years from today, you'll be able to appreciate it. Keep a watch on this machine unlearning. You keep a watch. Keep a watch on federated learning. It will be popular in a big way in the last 5 or 6 years because all of these are highly futuristic topics which you are discussing.
Mithun, so like to sum it up, uh, what I'm thinking is when there is kind of drift in data or something like that, gradient ascent would be a decent bet, and when there is like
See, I'll tell you. See,
compliance.
when you're talking about data drift, there are two things
Yeah.
basically. One is called as data. The data has changed, the model has changed, and your
Okay,
model
then I
performance has
think it
come
is.
down. Then basically you are thinking of basically rebuilding the model or any of these things. If you want, you can rebuild. If you feel that it's expensive, you have to come to machine unlearning itself. One of the many methods is gradient ascent. We are not saying that this is the only method. So if you have paid attention to this, where is that? This one. So you can see here there are 15 to 20 different algorithms, maybe even 30 algorithms. And each of these algorithms have their own flavors, they have their own merits and demerits. You understand this? So gradient ascent is a simple, intuitive to understand. There's a good algorithm called as a knot. Right, that's also a fantastic algorithm. There are so many algorithms basically under federated unlearning itself. All of these things that you're seeing are all names of the algorithms. So, for example, Fed eraser, that's an example of federated unlearning. Pruning, that's an example. SFU, that's also an example of your unlearning. So, maybe if to cover each of these algorithms itself, maybe one more masterclass we need. There's so much of
But like,
depth in this.
yeah, I understand. But like, based on I'm trying to relate it to what is ideal use case at what point. Because gradient ascent, I feel like when one of the statement has become outdated or something like that, or it is not useful in the current context, then I think gradient ascent would be a right fit. But if
Gradient
there is a
descent
like,
is the simplest and see, it's a matter of convenience. If gradient descent is the easiest and intuitively logical,
yeah,
because
yeah,
wherever it
logically
has
very.
very simple to cancel the learning. Dy by dx is positive, make it as negative. Dy by dx is negative, make it as positive. Very simple.
Yeah, and
changing reversal of the
intuitively
sign.
also, like it makes very much sense that
Which
the
one?
model parameters would be like changing in like very right way
Which one?
if we train the model oppositely.
Yes, 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 yes. So this is
And
the
like when there is a sensitivity like privacy issue, then we could apply that epsilon budget kind of thing.
yes, privacy
But when
budget.
there is like if like also if the influence of particular data points we want to remove is high, then we can utilize that epsilon like epsilon thing. If it is not so high, then we can directly use exact unlearning.
Yes, yes. These are all rudimentary methods. These are all mostly algorithmic method.
Okay.
So within this also data-based methods. So these techniques you're handling at the level of data. You're not changing the pattern. Here, these are architecture-based methods. This is federated method. Which means at the level of the device.
Okay.
Very interesting subject, guys. I don't know how do you find it, but it's a very interesting subject.
Level of like it happens in the device means like is it like a
The correction, since the
computing or
data is
something?
present in
I
the
didn't get
device.
this federated unless.
See, federated, whatever you're doing, model training is happening locally. That's the one point that you need to remember. So if you're talking about fed eraser, here the chance, the fed eraser, the first point is fed eraser. What does it do? Basically, it erases the data from the federated system from multiple devices. So let's say you're forgetting the user information from the phone's artificial intelligence. At the device itself, I'm providing the cure. That's what I'm saying.
Yeah, okay.
Yes. Anybody else has a question? Please ask.
Can I go
Yes,
next?
yes, please ask.
Mithun, is there any possibility of misusing this machine learning? Because if someone wants to intentionally misuse of this,
Deliberately.
right? So
Deliberately. See,
yeah,
one of the techniques itself, somewhere there is a caveat as well. How do you unlearn? Let's say, I'm just giving an example. Let's say, if I'm just giving a very rudimentary and simple example. If the income is greater than 1 lakh, let's say it predicts high income class, and some people have asked saying that my income I don't want you to use. It is greater than 1 lakh. I'm exercising my right to be forgotten. So here, what are we doing basically? Original model said if it is greater than 1 lakh, it is predicting high. We are going here and deliberately polluting that and putting many cases as low. Do you understand? If the income is greater than 1 lakh, I can manually go and put low. Why? Because now the model's learning itself has been trained. I'm confusing the model deliberately. Correct? So in the name of machine learning, anybody can misuse this.
how we can overcome this? Because again,
See again, basically, it's not that any Tom, Dick, and Harry. I said it in a very simple way. Nobody. It's not that everybody has access to this, isn't it? So typically, what they do is basically they check they check certain basic statistics of the data, like what is the minimum level, what is the maximum, what is the average. Just as I said, basically you have gone and you have basically changed all the contents. Firstly, it is not so easy because you may not have the permission to go to the database and inject these wrong values. You and I may not have so much of permission. Firstly, even if you end up doing it, basically the characteristics will change. Wherever it is high, basically if I put it as what did I say, good cases or low income class, you look at the proportion of people, basically they will change. Once the proportion changes, basically you'll come to know that there is a data drift. Data has been changed or manipulated or tampered. They can look at your username credentials basically and kick you out. Your
yeah.
summary statistics, simple summary statistics, minimum, maximum, you keep looking. Average, you take a look at. Percentage, you take a look at. Your job is done. All of these, naughty things which you're talking about cannot happen. Machine unlearning, guys, just remember this. This is a technical angle to it, right? Just remember, don't be under the impression that this is the only thing. Machine learning typically should be combined with other GDPR guidelines and such things. It should be combined with other non-technical things as well, so that basically your data governance is foolproof. This is the technical angle. There are so many non-technical things also you have to do, so that your data and such things, your quality of the data that you take, train basically over a longer period of time is good. Uh, all these data poisoning and such things do not happen.
Yeah, it's technical one, but Mithun, I'm not so experienced to quote like this, but it is going to disrupt this AI thing in the future.
Yes, it can. See, it's almost like a double-edged sword. Anything can be misused. Anything can be this thing. You should know how to just play around with this. You should know how to handle things. That's it. How do you find, guys? I mean, did you
Okay,
find this machine
I'll go
learning?
next.
Yeah, please go on.
So
Please tell me.
yeah, actually, I wanted to say that I have understood machine unlearning much better than machine learning.
You have unlearned the machine learning then.
With that in mind, actually, so before I ask my question, I just want to set some context, Mithun, that
Yes, please.
I have not read machine learning into a lot of depth. So the what you said in your presentation and your class was that we can actually check the accuracy of how good our algorithm with machine learning is, right? We have
Yes,
different
yes,
values that we can check, R square, K means, etc. But
yes,
there is
yes,
no scientific way to really understand how good our machine unlearning has happened.
yes,
Um,
yes.
Now, can we not do this, that we recalculate all these scores before and after unlearning and see a comparison of
It's
these
easier said than
scores,
done.
R square, K
See,
means, etc.
just think of it. Large language models, right? They have billions of parameters. Where all you'll check? Just it's easier said than done. Where all you'll check?
Hmm.
How much will you
Hmm.
check? Tell me. So this is like, very difficult when you have such a large language model with 1.2 billion parameters, which whose weight you'll reduce, where you'll reduce, how will you find out basically there may be 50 other layers. Very difficult for me to pinpoint and say, boss, I have done a good job here, I've done a bad job here. So therefore, one of the criticisms against machine unlearning, it's a criticism now, 10 years from now, basically, I'm sure somebody will find a solution, is that evaluation techniques are not robust here. That we have to admit it. And this is a evolving subject. There are more questions than answers.
And another follow-up question is that can we not build an agent out of this machine unlearning which constantly monitors our machine learning
Yes,
and
yes, yes.
continuously
Good
keeps
idea.
correcting it?
Very good idea. You can go ahead and do it.
I
Okay,
think
It is a
also,
thanks.
good
Thank you,
and
Mithun.
bad canceling out each other, right? Learning learns the pattern. This fellow cancels it.
I think also like in case of machine learning, usually evaluation is based on the comparing predictions to the actual values, right?
Yes.
But in case of like machine unlearning, it has to take into account the input should be even the prior model which we are unlearning, and also like the
Uh,
deviation.
yes.
Deviation is what we are trying to evaluate.
Correct. You saw in that one Python program, right? 89% we got after deletion, correct?
Yeah, yeah,
6% gap
yeah.
by just deleting one data point.
Yeah, the evaluation is kind of a different compared to machine learning.
Yes, yes. The behavior of the model when it saw these data points and it predicted, that behavior should not change after you remove. If its behavior changes, then gone. It should perform as if it has never seen those data points. It's like I'm training a child to recognize apples, but let's say, imagine that I've given it 100 apples, and accidentally, many times when through some accident of it, when those apples could have black spots. Now, I've not noticed it, but the child has noticed it, and it is thinking, oh, apple means, okay, it's a red fruit, it has two black spots. So next time the child is under the mistaken impression that only those apples which have black spots are apples. Otherwise, if you give a nice apple without black spots, it is not an apple. Now, what should you do? You should go to the child's mind and you should erase that part which basically you introduced and said, boss, there are two black spots basically which were fed to you in the training stage were wrong. Now you have to go back and erase this basically, right? So what do? Maybe you have to just give fresh apples basically, or so that the dominant category that you have trained the child on is good fresh apples without those black spots. If you do this substantially, it may forget the earlier bad learning that it did. Yes.
Well, Vikas here. I think it's
Please.
a very informative session, very insightful.
Thank you.
And
thanks.
I do agree with you that this is going to be the future. Because
Yes.
when I reach out to customers and have a discussion about what they are doing in their organization about LLMs, I think most of them are not able to answer this, how exactly they will make sure that models are compliant to whatever governance framework that we have in
Yes.
India and across India. And in
Yes.
one of the very recent interaction with very large IT/ITS customer, so they evaluated our, so I come from cybersecurity background, so we do have a lot of products which make use of machine learning very extensively.
Yes.
So Chief AI Officer, this is a designation I heard first time, and
Yes.
I got an opportunity to interact with her, and she was very thorough when she was asking questions about how this model is being trained, what kind of data set you have used, what is the source of those data sets.
Yes.
I think
Yes.
that's the future, because that IT customer has a customer base in Europe and in US. I think without machine learning and AI governance, it will be extremely difficult to operate in global market as well as in India.
Absolutely, you're right. There they take privacy and such things very, very seriously. They started taking privacy very seriously.
So one more question I have. So I'm working on a project. Is it possible to connect with you offline for half an hour, 45 minutes?
Yeah, no problem. Whenever you're free. Yeah.
So can you share your LinkedIn profile, please, in the
I'm
chat?
not very active in LinkedIn. How do you connect?
Or email ID should be okay. I will put a request.
Yes. So K Mithun, I'll just write it for you in the chat window. Yes, somebody had a question. Please ask. Yeah, I've shared it. Yeah.
Thank you.
No problem. Anybody else? Any questions? If anybody is doing any PhD and such things, take this as a topic. I think you'll like it.
This
Yes.
is Sriram sir. As because I was totally beginner on this matter. What I'm
totally?
trying to learn is totally beginner in this machine learning field.
No problem.
So what I am trying to learn now is how to train the model to get the desired output in my domain expert. Suppose I'm
Yes.
getting a contract filings or like documentation verifications. So we're just trying to have lot of data and training. Now this topic, what you told me, we're coming to know. So one side we have to go on updating the data to train it to make the neurons perfection, give the data
Yes.
exact data.
Yes.
Other side now, what has been solved now, unlearn it means you are diluting your output. At the same time, you have to maintain the privacy. That's a trade-off, or you have to make the balance now.
Correct.
So this part, I think when you go for a domain, as for data, it is okay, but your personal data. But when you come to any
Specific
specialization like specific field like
healthcare,
manufacturing or
finance.
healthcare or like this finance, so they need models have been trained with a lot of data, but unlearning how to handle this, we
That is
have
a
to keep
challenging part you see there.
we have to keep an agent to keep
Yes.
popping every time there's now the data is removed, and this is the model now going to change those.
Yes.
And at the same time, we are saying that the same output should not be what to say, this same output will come out without affecting its original outputs.
Correct. Correct.
So, sir, how to bring this balance, or is there any tool which we can try on with this data? Suppose in my field is in construction, and I'm doing in contracts administration, and we have so many data where we find like one plan is given, you upload it, everything will be designing and models will be coming out. The more
Oh,
data you feed out, the more results will be accuracy. But unlearning at any point of stage, the design will be manipulated or compromised at that stage.
Yes. Yes. Yes.
So, sir, is there any tool, sir, when we can apply unlearning at this stage also to see? Suppose if I'm training my data, parallelly I will see also by unlearning at that stage what is the effect on this.
Parallelly, it's a bit difficult. I don't think we have any ready-made answers as of now.
Okay, sir. So once we have to fine tune the model, then only we can think of
Yes.
this
Yes.
better.
Yes. Yes. Train the model only after some gap. Basically, if it's operational, then if you want, you can go back and
Yeah,
unlearn.
fine.
Parallelly only, it'll get confused.
Difficult, sir. So once it is modeled, is fine tuned and implemented, train tested. After the gap, then we can unlearn and see what effect is coming out for at each stage and which parameters is getting affected due to this.
Yes.
Okay, sir.
Okay. If there are no questions, shall we wind up?
Yeah, Mithun.
Okay. Thank you.
thank you,
Bye.
Mithun, for this
Thanks.
session. Yeah, really always useful and very interactive, very energetic.
Thank you
Thank
so
you,
much,
sir.
sir.
Thank you for
Thanks.
your guidance.
Bye
Thank
bye.
you.
Take care.
Thank you.
Thank
Bye-bye.
you so much, sir. Thank
you.
Thanks a lot. Yeah. Thank you. Thank you.
Thank you.
Bye-bye. Thanks a lot.
Both the sessions were very interesting. Previous one and new one. Very new
Which
concepts.
which one? Yeah, previous one.
Explainable AI.
Explainable. Yeah. Okay. Glad you liked it. Yeah. Thank you so much.
Sir, I will be having some messages regarding explanation AI, sir, because my project is more on the explanation AI. So I will be sharing something points for you, sir.
Sure. Definitely.
Please. Okay,
Thank you.
thank you.
Thanks. Thank you. Bye.